So, how many of you were here in my last talk, like last year? Okay. So there are still a couple of new faces here. How many of you have actually used RX before? Okay. Okay, good. So the left section are newbies and the right section are experts. So I'm actually going to do a bit of both. Like I'm going to talk in general of like what RX is. We have sort of a new way of sort of telling about the different layers in the system, which is actually do a lot of use to everyone here. I'm also going to talk about some of the stuff we've done to make RX available on Windows 8 and .NET 4.5, like some of the enhancements we've made there. In fact, I'm going to do a little demo with most likely the Windows 8 machine over here. So just to show you that nothing is different, even though, like, you know, the underlying platform has changed, RX always stays the same. And if there's some time, and actually there will be lots of time, I will also show the Kinect demo today. So there's a lot of stuff here going on. So as a matter of introducing RX, I sort of want to step back a little bit and sort of tell you where we're coming from. In fact, like when we started the RX project, and was before I actually joined the RX team 2.5 years ago, there was actually some RX work being done already, like sort of like early phase of the project. It turned out that the event processing thing we were doing was actually just a small layer, small piece of glue in between different layers of a bigger system. And as it often goes, like you basically start to dismiss that little piece and you say, that's trivial, that's left as an exercise for the reader, you know, we'll just do that over the weekend or something, and the rest of the system is really what we want to focus on. Turns out that that rest of the weekend kind of thing turned out to be a journey of like 2 to 3 years, where we actually built just the glue. And so we said actually the glue is more interesting than the whole big picture that we were sort of after at that point, even though we're still pursuing some of the bigger things as well. And in fact, we see RX being used now in a lot of our cloud assets, like, you know, System Center team, the Windows Server team, some of the Windows Azure teams, the Bing team, all of them have some kind of dependency on RX for their event processing system. So after all, things are coming back where we sort of started. Now, what's the main observation that actually motivates doing event processing systems today? Why are we building something called reactive extensions to make event processing simpler? Well, this is actually the slide that sort of has the observation. The observation is that when you look at your application today, the way your application receives data is fundamentally different from the way it received the data a couple of years ago. What do I mean with that? Well, if you look at your application at the center of the world, much more data is coming into the app in an event-driven way. Think, for example, about stock tickers on the internet or RSS feeds or social media, just as a couple of examples. Think of Twitter, for example. Like the way Twitter comes to your application, well, even though behind the scenes it's maybe based on HTTP GETs and all of that kind of stuff, really the way you want to program it is as a stream of data coming into your application. You want to react when data becomes available from Twitter. You don't want to sit there and call the Twitter servers every couple of seconds to see, is there a new tweet about this topic? Instead, you want to sort of have a programming model by which you say, there is an event stream of tweets coming into my app, and now I want to do processing of those tweets based on query language. Other examples include things like GPS and all the sensors that you have in, you know, Windows slates and, you know, phones and all of those things. Like this just has a boatload of sensors like accelerometer and all of those kind of things. Well, all of those guys are really event sources. And the way your application has to program those is not by asking what are the coordinates of the system. No, the system is telling you that something has changed. And hence you have to react to that particular event coming into the system. Same for example, the service management space. You don't want to query your entire data center of 5,000 machines every second to see whether one machine is down. Instead, you want, you know, some watchdog processes to be there, sort of monitoring the system, and then notify you when something goes wrong. Otherwise, you have a system that's not doing anything but just spending its entire life pulling the entire data center. That's not a very, very nice way of programming things. So you actually want to have events in the system as opposed to a way of actually retrieving the data explicitly. And so that's what we do with reactive extensions, is basically unify all of those event sources. Because like we all have those things today, but if you look at the APIs, well, if you have some stock ticker service, maybe it's web service calls with a certain callback mechanism. If you look at Twitter, it's likely yet another protocol that you have to understand and support. UI events come as .NET events. Maybe those sensor data things are looking slightly differently. There's no unification between all of those things. So what we say in Rx is we're going to unify all of this by means of a single abstraction, and then we're going to build a library on top of that that makes processing those events easier, no matter where they come from. So this brings us to the sort of pivotal slide of this entire talk, which is like the layered cake diagram of Rx. So we'll actually talk about the 3 layers here. First of all, I will actually talk about the event stream aspect, which is the middle section there, which are the core interfaces that we use to unify all of those different kinds of event sources. Then we have a concurrency layer. That's the last thing I will talk about. That's where actually work happens in the system. You can sort of think of this as a virtual machine on which we built a query language, right? Like for example in SQL, you have a storage engine and a SQL operating system, and then you have a relational engine on top of that. Sort of the same abstraction here, like the same separation of concerns. Then at the very top, finally, you have link to events. And so link to events really is the way you should approach Rx. It's really the API service, the place where you actually start gluing together different event sources, and where you actually define the queries you want to execute. Maybe you want to say something like, you know, I have the Twitter service and I want to count the number of mentions of Lady Gaga every minute. So you want to write something like buffer this thing in chunks of 1 minute, do some analysis on top of that. Like that's the kind of queries you can ask on the top here. And if you look at this picture, really it should be drawn as a pyramid upside down. The bottom layer is really small, but it does a lot of stuff. The event stream layer is just a couple of shallow interfaces, which are really the core abstraction. But then linked to events is this huge API service of like tens and maybe even hundreds today of query operators that you can put on top of those observable sequences. So we don't have the time to talk about all of the green layer. Like this really deserves a whole book of its own. But so I'm just going to sample each of those sections so that you sort of understand the core principles, so that you can also start exploring the top layer on your own as we walk out the story. And so let's actually zoom into the middle section to begin with, which is the event stream section. Like, how do we unify all of those different event sources in the system? And so looking at that, there are 2 parties in the picture, and maybe you've seen this picture before. Like if you've seen Rx before, you might have seen this like, you know, little lightning bolt kind of picture before. But so the essence of this slide is really that there are 2 parties. There's the party called the observable sequence, which is the guy who has the ability to send you data. You just have to ask for it. You have to tell him, well, hey, I want to receive notifications when something happens in the system. And that's what the observer does. The observer says, please call me back on those methods whenever something happens. It's like an event handler. A continuation. It's exactly the same sort of relationship between the 2 parties here. You can draw lots of analogies. Typical analogy I actually make nowadays is like, for example, newspapers. Well, people still know newspapers today. In a couple of years, most likely, you know, the young people will say, well, is that a newspaper? Like I read everything on my pet devices. But so, in the context of a newspaper, the observable is really the publisher, right? It's the guy who publishes the newspaper. And if you want to receive editions of that newspaper, you're basically gonna subscribe to the newspaper by telling the publisher, I want to get notified when there's a new edition. In fact, I want to get the new edition every time there's one. And so you give it the observer, which is really your postal mail address to send the magazine back to as soon as it comes out. And then finally, at some point in the future, you will get, you know, notifications whenever some of those things arrive in the system. This particular case, newspapers, and in the case of the slide, stock tickers, all of those kind of things. And the most important thing here is it's asynchronous, meaning you subscribe to it and you go on with your life. You do whatever you want to do next. And in a future point in time, you might actually get called back on the observer to receive a piece of data. So data is being pushed into your application. Which brings us back to the first picture. It's really the cloud sending you that data, right? Like, you know, you're not sitting there and waiting for something to happen. Like, I still have to see the first guy who basically puts a subscription to a newspaper in the letterbox and then waits in front of his door for the first edition to arrive. That's kind of totally bananas. And maybe there are people who do that, but like, we don't want to cater for that. So, how does this reflect itself into the core interfaces, which are the interfaces that are in the BCL today? Starting with .NET 4, we actually have those in MS Core lib. In fact, on Windows Phone 7, they live in a different assembly called system-observable.dll. That will change in Windows Phone 8, with standardizing everything into MS Core lib there. So those are the two interfaces, iObservable and iObserver. Most important thing here is not really so much about the callbacks. We'll talk about the callbacks in the next slide, which is the onNext, the onError, and the onCompleted channel. We'll talk about that separately. But what's really interesting here is the way we do the subscribe. This is really something fundamental, and I actually have a slide about the layering of the system later, where you will see this coming back. Notice what the subscribe takes in. The subscribe takes in the observer. That's the place to call you back. That's the place you want to get your notifications by means of calls to the onNext, onError, and onCompleted methods. However, what it returns is also very interesting. It returns an iDisposable. That's the guy you can hold on to cancel the subscription in the future. So you basically get some kind of cancel ticket back. It's like if you subscribe to a magazine, you get a little piece in the mail as well that says like, if you no longer want to receive editions of this newspaper, please mail this little piece of paper back. That's your disposable object to dispose your subscription. And so what's really going on here is we want to have composability, and I will explain what that means in just a moment, both on the data flow. If you have multiple observable sequences, you want to be able to sort of aggregate those guys, merge them together, like you want to do all those rich compositions on those guys. But as a result, we also need to be able to do composition on the dispose channel. What does that mean? Like, if you have multiple sequences you're listening to simultaneously, and maybe one has to be listened to after the first one completes, like all sorts of sequencing operations, and at some point somebody says, I no longer want to listen to this particular query, we have to dispose every dependent object, right? Like we have to dispose all the underlying subscriptions. Maybe we're subscribing to 10 like sequences under the covers. And so the iDisposable allows us to actually centralize that dispose logic in a very fluent and compositional way as well. We'll actually see that later on as I talk about that. But so that's first things first, like let's take a look at what you can receive in your mailbox if you subscribe. Like what are the notifications you can get back? And so this is the notification grammar. If you look at the picture here, this is a timeline, we call it the Markov diagram. And so you see source 1, when you subscribe to source 1, at some point your observer gets message 42, saying like this sequence produced a value. Maybe that's the June edition of a certain newspaper, you can substitute it for that if you like as well. Then you see onNext of 43 at some point in the future, and then you see onCompleted saying the sequence is at its end, which means there will be no further notifications received. Okay? So messages can actually indicate termination of the sequence as well. Then you have source 2 here, which is another example. This is one that actually fails, and so it completes exceptionally as opposed to gracefully. So we have two ways of terminating a sequence. Now sequences don't have to terminate, like mouse moves, like if you have an event sequence of mouse moves, typically there's no completed or error message on that thing, like your mouse simply keeps going, even if you unplug it, like Windows doesn't raise an event saying the mouse has been unplugged, please, die as an application or something. Like there's no exception of unplugging a mouse or something. So those sequences can also be infinite. Like those are just two examples. And so to really sum it up, this is like sort of the more formal specification of the message grammar. You can actually get any number of onNext calls, including 0, including an infinite number of those guys, followed optionally, that's the question over here, with an error or an uncompleted, which means the sequence terminated successfully or exceptionally. So that's basically the grammar. One thing that's not on here is like the fact that you can't get concurrent notifications. Like if you subscribe an observer to an observable sequence, you don't have to protect your onNext handler or your uncompleted handler against like reentrancy and all sorts of messy things. Like there can't be multiple calls on the same onNext method at the same time. Like it's still a sequence. It's a sequence which means that things happen sequentially. So one message has to be delivered completely before the next one sort of goes through the system. So there can't be overlap between those bullets. You can't have them sitting on top of each other or something. They may actually do something like that in the future, because if you think about like what Rx actually is, it's sort of the analogy to link to object but for event streams, right? Like link to objects is about querying like collections and memory collections. Now we have link to events, which is really the active extensions. I have a picture about that later on. Now, people who've been watching carefully what we've done in the .NET space with link to objects is we introduced this thing called parallel link, right? P-link, which actually parallelizes the execution of an enumerable-based query. Well, maybe we could do something in the RX space as well. And it's sort of like an interesting exercise to sort of think about what that would even mean to parallelize like an event sequence. Like that's something to sort of like stand still for a little moment there. Like it's actually possible to think about that stuff as well. But so today, no overlap notifications on next on error complete. So obviously there's the big question, why are we doing this, right? Like, isn't there already a way of doing event processing in the .NET framework? And the answer is yes, we have .NET events, and in fact we made .NET events sort of like something that's built in, that every language knows about. It's in the common language specification, and we say like, you know, a .NET event is a piece of metadata that has an add and remove method associated with it, blah, blah, blah. And that's the thing that actually gives you the ability to have those lightning bolts in your IDE, where you sort of say, this thing has 15 events, and you can discover them using reflection. It's all beautiful. You can double-click it. You have an event handler. You can write your code. You don't have to implement things like listener classes, blah, blah, blah. Like, it's a very nice way of doing tooling, but there are some fundamental limitations to .NET events. And let's actually talk about that in this slide. So this little piece of code does just some stock tick analysis. Actually gets events, stock ticks, and it just uses a lambda expression here to filter the stock ticks based on the symbol. And whenever there is a Microsoft stock tick, I will do some piece of code, maybe to render it in the UI, or maybe to do more analysis, right? And so when you look at this piece of code, there are really 4 problems with it. The first problem is, and that's really the problem out of which most of the other ones sort of fall out. You can't pass events around. If you have 2 parties in your application, one that says, hey, we are going to do a GPS visualization service, or a stock tick visualization service that draws nice diagrams as events come into the system. You need to define a contact between the UI junkie and the code junkie. Like, you know, the UI guy who's doing all his sample stuff, blah, blah, blah. He needs to have something that tells him when things have changed. He needs to have some object that actually tells him when there are new stock ticks. And the other guy needs to have something on which he can say, there is a new stock tick, I was listening to the web service, I was doing all this weird processing on the networking layer to receive the stock ticks. Like, it's not as easy as saying, just let's define a class that has a constructor that takes in the .NET event. A .NET event you can't lift up and sort of give to somebody else. So you have a big problem there. In fact, if you look at methods in .NET, methods actually you can lift up. Methods you can lift up as delegates, then they become objects, and then you can give the object to somebody else and he can still call the underlying method. The .NET events, properties, indexes, constructors, finalizers, all of those guys don't have first-class primitives. You can't lift a constructor, for example, into, you know, a delegate or something. Yeah, you can sort of make a wrapper around it. You can't do the same thing for an event. An event is really 2 methods in disguise, an add and a remove method. But there's no first-class representation. And so you can't define this crisp boundary between 2 parties. Secondly, they're hidden data sources. What do I mean with that? If you have a stock tick and you get the event types, like you were double-clicking on the stock tick event and you're sitting in the wonderful world of curly braces and semicolons or and statements in VB, and you're sort of like looking around like, I have my event handler, where's my data? You have to go into the event types and dot into there, and often enough, it actually doesn't give you anything meaningful. Like, you have the event type sitting there, but the data that you're interested in is not there. Maybe you have to pass the sender to the original object and fish the data out. Like, it's really like kind of a hidden ceremony kind of thing to sort of get the data out. You need to do a little rain dance, and then you see, there's a quote inside the event types. That's beautiful. Third, and this is really an implication of the first thing, you can't pass those guys around, is there is lack of composition. Everyone can write an if statement inside an event handler, right? But like, if you do that 15 times, you sort of start wondering, like, couldn't I abstract that? I have an event and I want to filter the event. Wouldn't it be nice if I could do a where clause on top of an event to get a derived event that only fires when the condition is true for the underlying event? Like that kind of stuff you can't do, because you can't pick up the event to define a method on top of the event to basically do filtering. So you have a lot of problems there as well. In fact, this is an innocent looking if statement. That's totally fine in a lot of cases. But think about it, like, what would it mean to, for example, sample the stock stream? You want to sample the stock stream every second, because there are like stock ticks coming into the system every 15 milliseconds or something. Well, in order to do that, you need to hook up an event handler and you need to start a timer. And the event needs to write to a field, and the timer needs to read from the field. Maybe the field needs to be volatile, because there are two threads over here. Maybe one will not see the writes from the other, and that kind of la stuff is going on as well. Like, there's a lot of things to start thinking about. And at the end of the day, what you've done is you've modified your class to have like a field over here, a log object over there, a timer over there, a callback over here, blah, blah, blah. And at the end of the day, you're not dealing with events anymore. You had an event to begin with, you double-clicked on the event, and you lost the fact you were in the event world. Now you're in the curly braces and semicolon imperative code land. You have to do everything yourself. And so you can't use that logic. You can, at most, you can give somebody a cookbook to say, if you want to sample a .NET event, add those 15 fields over here, add those 3 logs over there, a little bit salt and pepper, and everything is good. But like, that's not what we want. We want to write that code once and for all on top of any .NET event. And then finally, which is also an implication of sort of the first thing, but a little bit harder to see, is the resource management. And the resource management is also the thing I'm sort of thinking about when talking about sampling, for example. I was explaining this whole way you could do sampling with .NET events, like start a timer, write to fields, blah, blah, blah. How do you say, at the end of the day, I'm no longer interested in getting sampled data from the stock stream. I want to stop listening to that stuff. Now you have two things to worry about: stopping the timer, stopping the event subscription. Maybe you forget to stop the timer, but you didn't actually dispose the subscription to the event. You unhook the event handler. What's happening at that point? Well, your timer is still going and reading stale stuff from a field somewhere. So you need to now dispose two things. You need to get rid of the event handler, you need to get rid of the timer. And maybe there are interesting race conditions as well. Like, so there's a lot of stuff to sort of think about. In fact, in this slide, I don't even know how to get rid of the event handler. Like, it's impossible without changing this code to actually do it, because I use an anonymous method over here. I need to do minus equal with the same instance. I don't know what the instance is. I just assign it. Like, I need to assign it to a private field to sort of keep track of the original delegate instance to be able to do a minus equal on it. So, a lot of problems there. So, how do observable sequences make everything better? The answer is, it's actually one thing in this slide that actually is the summary of the whole slide. And the devil is in the details. I was actually making sort of a little note a couple of weeks ago to somebody, and I was showing this slide for the very first time. You know, I said, people in marketing actually like to use this symbol, this 3 dot symbol, right, for etc. in a lot of places, because they want to look smarter than they are. They say, like, I have 5 bullet points, etc. There's a lot more stuff to worry about here. Like, there's a lot more things that you need to see in this slide, but I didn't have the place to put it, or the font became too small. Like, that's the common trick they're doing here. Here I'm actually proud of the 3 dots, because that's the essence of the slide. The fact that, you know, I don't care where those unobservables come from. Somebody passed them into a field, through a constructor, in a property, whatever. Like, they are first-class objects, and because they're objects, I can pass them in anywhere. That's the first thing. I can mock them, I can do all sorts of fancy stuff with them. Secondly, so you definitely can pass them around because I'm not even telling you where it's coming from in this case, and I'm proud of not telling you in this case. Secondly, they're actually no longer hidden data sources. It's an IObservable of T. What's in the IObservable? T, right? You know, like, you can clearly see what's the data inside. In fact, when the CLR team back in 2003 or something started working on generics, they distributed for the entire CLR team coffee mugs that said cup of tea on it. Like, you know, it's a cup that contains tea. Some people poured coffee into it, but that's the beauty of generics. You can substitute the tea for something else. You can have a cup of juice as well using that thing. So you can clearly see what's inside the cup just by seeing, oh, it's a generic cup. I can pour anything in it. So that's beautiful. You no longer have to worry, like, what does this thing produce? Let me look in the event logs. I don't know what it's producing. No, you now clearly see it. It's actually in the time. Third, because you have this dot 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 thing, you can pass those guys around, you can actually define operators. You can define a method that says, if you give me a cup of tea, right, and you give me a heat source, a function that goes from tea to hot tea, I can give you a cup of hot tea back, right? Like, I can define those operators on top of it. Of course, you don't want to have like something that cooks your observable in this case. What you want to have is something like a where that says, hey, if you have an observable sequence for me and you have some way to filter it, which is a function from t to boolean, a predicate function, I can give you an observable that's the filtered result, right? So you can write all of those operations yourself now. And in fact, we do a lot of that stuff in Rx, of course. And the resource maintenance becomes so much easier. Again, I'm proud of the dots here because I don't care what's in the dots anymore. Like, I just forget about that thing. The only thing I have to remember is the subscription I get back. The subscription is my ticket to be able to unsubscribe in the future. Now, this is important because, like, now you can start thinking of how that sampling works, right? Say, for example, you have an observable of t. Now I can write a sample method that takes an observable of t as well as a time span, which is the sampling period or the frequency, and then I get an observable of t back, which is the sampled sequence that fires every time, you know, there is a sampling happening, right? Under the hood, I have to subscribe to the original source. I have to subscribe to the original observable, the original data source. I also have to start a timer. How do I allow people to stop that whole contraption of a lot of things happening in the system? Well, I got a disposable back from subscribing to the original source. I started a timer, which I can actually create a disposable object for that cancels the timer. Now I have two disposables, a subscription and a timer. How do I give you back a disposable that cancels that whole thing? I just create a disposable that contains the two other disposables inside, the so-called composite disposable. So you're now composing a sequence and a timer, maybe 15 sequences and a timer, like all sorts of things. And you're also bundling up all of the resource management into iDisposables. So this is actually what this allows you to do. So let's actually, oh, I have one more slide before I'm going to do some demos here. Are .NET events obsolete? I got this slide recently because there's sometimes confusion whenever you say, this is the new shiny world of unicorns and rainbows. People say, but you know, I sort of like my horses in the backyard as well. Like, and I only get unicorns now. Do you have to throw out my horses? The answer is no. You know, both of them are useful in certain cases. So .NET events are not obsolete. The way to think about that is by going back to my analogy, right? My analogy with .NET events, not .NET events, but .NET methods and delegates, right? .NET method is something you pick up using a delegate. You take a .NET event, you make a delegate out of it, and you can pass it around to other people. And they can start writing libraries on top of delegates. That's beautiful. Does that mean that we're going to throw away like methods in the VCL or in the CLR? Saying like, we don't need methods, we just have delegates. You can pass delegates around now. Well, where do the implementations live of those guys? Like, that answer is sort of like not there. So the same thing for .NET events and observables. .NET events are the thing that's in the framework, right? They're very primitive, low-level kind of functionality, just add and remove methods. And if you want to lift them up and give them to somebody else, maybe to write a library on top of it, that's where observables are sort of looking around the corner. Which means that you don't have to have exclusion between the two. So just a couple of things here. .NET events are totally fine if they are to be used code-centrically. What do I mean with that? Well, if you have a button-click event, typically the button-click event isn't really about data processing. In some cases, you can sort of try to think about it that way and do something meaningful with it, but in 99% of the cases, a button click is waiting to be double-clicked in a designer and write some imperative code to do a message box.show kind of thing, right? That's imperative code. That's code-centric. Now you have a Kinect sensor. A Kinect sensor gives you like a stream of skeletons that are happening 30 times a second. You know, the user is dancing, blah, 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 that kind of stuff. Like, do you want to write event handlers for that? Well, maybe you want to look at it as a database of points that you're analyzing over time. What's the user doing? At that point, if you're in the world of a code-centric experience, you end up with lots of fields and timers and this and that. That's not what you want. In that case, observables are nicer. Which doesn't mean that the underlying API couldn't be based on .NET events. It's just like you say, yeah, you give me .NET events, which is very efficient, very nice, but I want to do rich things on top of it. let me move it into the world of observable sequences where I have all the power of Rx at my disposal. Design time experience, we talked about that sort of like in passing. But here are sort of the implications, or sort of like design where observables are different from .NET events. Observables are first-class objects, you can pass them around, they're objects, that's the basic idea there, which enables rich composition, which also means they're slightly more fast. Like if you have a huge framework that has millions of events sitting there, like classes that define events on top of them, you may not want to expose them at the base layer of the system as observables, because observables mean you have an object that people come to. Like if you have a button and it has a click on it, now you would have two objects. You would have the button object, which has a pointer to the click observable. Like you would have more objects in your system. That's typically not a problem, but like if you build an entire framework on top of that, and you have all of those events, like click events, that are meant to be used in a non-data centric fashion, typically you don't want to end up having all those little objects sitting there. It's only when you want to do something additional. Exactly the same thing with delegates. When do you lift up a method as a delegate? When you want to pass it to someone. That doesn't mean you can't just call the method without using a delegate, right? Like you could do everything functional style, saying message box is an action of string, dialog, options, comma, all of that stuff, and then just use that thing. You're kind of nuts if you do that, with all respect. Well, you know, it's not that bad. In certain cases it's justified to do that, but typically that's not the way you want to layer your system. You don't want to have the rich objects at the bottom. You want to actually lift them up at the point you need. And there's one more thing that I will actually talk about here at the end of the talk, is like the execution model for events is very rigid. You can't really influence it. People are trying to see the bottom of the slide, I will just read it out loud. .NET events have a rigid execution model. Observables have a flexible execution model. What do I mean with that? .NET events, if you double-click them, you're in the world of C# or VB code, which gets translated into IL code, which means at runtime you can't really see what the user is writing. If you have an event handler with an if statement inside of it, I can't interpret that at runtime. Why would you want to do that? The CLR is already doing that. Well, if you have a stock stream, and the user wants to filter the stock stream to say, I am only interested in stock of Microsoft and Intel, like, if the CLR is the only guy who can see it, it means you have to stream the whole stock database to your client to filter it over there. However, if you can actually pick up the expression of the user saying, I only want to have MSFT and Intel as an expression tree, you can take that up and translate that into some query language that NASDAQ understands. So you can actually translate the intent of the user into a remote machine. Just like Link to SQL is about using the same syntax in C#, but the thing that executes it is a different party. It's the SQL engine, because you're generating T-SQL at runtime. The same thing you can do over here. So we'll talk about that near the end. So let's actually go into Visual Studio and do a little demo here. And maybe I should go to the other machine straight away here. Actually, let me go to the other machine immediately. So I have to do a little bit of hardware management here. I'm the software guy, so this may actually be a disaster. So this is a beautiful Windows 8 machine. I'm just going to do some Windows 8 demos here. You can do all of this stuff using Silverlight. You can do it using Windows Phone. You can do it wherever you dream. But so I just wanted to show you it also works with the new world over here. So I just want to have Visual Studio. So let me start Visual Studio over here. And oops, I didn't want to click that. I want to disable that guy. And so let's actually create a new little project here that ultimately will use Rx, and I will do a map to app, even though I'm not a UI designer. I will dare to do this once and for all. I'll create app 4. In fact, I'm lying because I already created 3 UI apps apparently. Oh, and I need a license. Okay, that's beautiful. I thought I already had a license. Okay, I will have to sign in, so just give me a second here. That's the brave new world of like application stores. So I'm just gonna do a classic demo we always do, but we're gonna sort of look at some of the new things we have in RxV2 in passing. So it's gonna be the good old dictionary suggest. Later I'm actually gonna show you the Kinect over here as well, which is a totally different demo. But like, for ones that actually have seen my session last year, they'll be sort of a little bit the same, but there are some subtle differences, so you can enjoy it as well. the others will actually see the richness of Rx over here. And so the richness of Rx doesn't include the button actually. I'm making a mistake here. This is kind of sad. What I want to have is a text box, I believe. And that's a no reference exception I've had before, I know that. That's because it's not shipped yet. So I'm just going to add a text box here. That's beautiful. And I'm going to add not a list view, but a list box. Don't ask me the difference about all of those things. Like somebody had to tell me, you need a list box for that, not a list view. So I say, okay, that's good. A list box it is. So here we go. That's my UI application. It's just beautiful, isn't it? And I'm going to give this guy a name as well, which will be LST, like this. Let me see whether it actually builds. So here we go. We have our little UI application, text box and a list box. That's beautiful. It's Matto, no rounded borders. It looks very nice. That's at least what designers tell me. So, actually, have you seen that the Higgs boson was sort of discovered, or people think it was discovered a couple of days ago? And so there was a big scandal on the internet that the guys who actually published, the presentation or something used Comic Sans, like one of those fonts, and designers say, "Oh my God, this is just like too sad to be true. Like, such a big discovery. You're using Comic Sans." Like, I would say, I don't care. There's the Higgs boson. Like, that's important. Like, no, it's Comic Sans, or it's like a rounded border there. That's more important, apparently. So, I have to believe people that, squares and rectangles are the way to go nowadays. So, what I'm going to do here is I actually want to have the effect that when the user types in the text box, we're actually going to download something from a web service that renders, what the user is typing. Now, you may know in .NET 4.5, everything is based on task of T. That's where differences are coming in with RxV2. Task of T is the new way of doing asynchronous single-value programming. And so there are some interesting changes in here. Actually, they don't even show up in the UI that much or in the code that much, but I will talk about it behind the covers. So what I can do here, that's also new actually in RxV2. As you can see over here, the references thing just shows .NET for Matto and Windows. It doesn't show all of the assemblies. In fact, if we would show all the assemblies for .NET for Matto style apps, I think it would be 50 or so, because they actually refactored all of the assemblies. They said system.core is system.core.link, system.core.io, system.core.reflection.emit, system.core.this. Like, they went through a refactoring exercise to actually be able to componentize the framework and run just the minimal set on servers and this and that. And so they actually went for this new model called extension SDKs. So you can actually do an add reference over here, and when you install Rx, you will just have a single checkbox here called reactive extensions, which includes all the assemblies. In the case of Rx, that's 5 assemblies today that are actually required. But you don't have to see that. It gets packaged up for you in the App Store. Like, everything is beautiful. So I'm just including reactive extensions here. And next I want to go to the example over here and start doing a little bit of work. People told me it's also bad practice to put like code in the load event or something. You have to do it in the constructor or whatever. So I'll just do it here. That's easier. Anyway. So what I want to do is I want to take the events from the text box. Let's actually take a look at the text box, how it looks to actually do event processing on that guy without using Rx. If I say text.text changed plus equals and I create a new event handler, it starts to look a little bit more promising than it was in, say, for example, Windows forms. Like, you sort of start drooling out the corners of your mouth and you see this text changed event tags. Ah, that's so beautiful. It will actually tell me what the text is that has changed. So you actually look at text changed event tags and you see, it just inherits from routed event tags, but it doesn't add anything. So this is just an event type for the sake of it, just to show like we are strongly typed, we know what we're doing, but in reality it says like we don't have anything to tell you, but we're still strongly typed. So you don't really see the string that has changed in here. So the typical way you have to do that is you have to cast the sender back to the text box, or maybe you have a field that already has a text box. Like, a lot of plumbing is going on there. So we don't want to have that kind of problem in Rx. So let's actually go here and convert the event into an observable sequence. Why do I want to do that? Once I do that, I have all those rainbows and unicorns and the green grass fields of Rx at my disposal.
where I can actually do lots of query operations. I could sample the stream, all of those things. So I'm going to convert the sequence here using observable from event pattern. I will explain this guy in just a second. And I will go, just for the sake of simplicity, later in the Kinect demo I will use a different overload. I will go for the reflective overload. You can love this one, you can hate this one. I like it for presentations, I don't really like it for maintainable code afterwards. So I'm just using this one for convenience here. There's an overload that's strongly typed and statically typed, you know, and it types a little bit more. But the thing is, that's on the edges. That's what you do to sort of get into the world of Rx. That's like creating a delegate around a method. This is like creating an observable around an event. Once you're in there, you can do lots of crazy, interesting stuff. So now I have my input. Here we go. And what I want to do now is say input.subscribe. Remember, an observable has a subscribe method that takes in an observer. And I want to pass in an observer. Now, where's the observer that I want to pass in here? Well, there is an overload that actually takes in an observer. That's the main overload. That's actually the one on the interface, takes in the observer. But that's kind of nasty to implement an observer for all of those guys. In fact, we don't recommend you to ever implement iObservable of t or iObserver of t, because those are pretty hard to actually get right, because there's lots of semantics in terms of the grammar and non-overlapped calls and blah blah blah. So instead what you do is you pass in to the subscribe action or the subscribe method, you pass in an onNext handler, optionally also an onError handler, and optionally also an onCompleted handler. So you say, this is a little piece of code you need to execute whenever something happens. We'll actually make an observer around it that actually has all the right behavior. There's even a little lock associated with that thing for certain edge cases. So there's more going on than just trivially implementing the interface. So what I'm going to do here is input e goes to, just using a little lambda. And so now I'm in here and I can actually dot into e. And what's e? If I dot into that, I see event args and the sender. That's still what you had with .NET events. You're not losing anything. You still have everything you had before, and it's still statically typed. In this particular case, the event args don't contain anything because, well, we saw before that the event args didn't carry any meaningful information, right? So that's nice. I haven't gained anything. Why are you telling me this? Well, you have gained something. You're an observable now. Because you're an observable, as you do input dot, look at this. You get like, you know, this whole sea of like things on it. Like, you know, timestamp, toArray, time interval, throttle, take while, take until, scan, sample, zip, blah, blah, blah. Like you have all those rich operations that you can do on the event now. One of the things you can do is say like, whoever designed this event, that guy was crazy. Like, you know, this thing doesn't produce at all what I expected it to produce. That's a typical scenario of somebody walking up to a database you've never seen before and you're looking at the schema and you say, oh my god, like, who created this schema? It's a product table and everything is prefixed with products. Product price, product name, product this, product that. Like, you say, I don't want to see this. What's your recipe to shake off the things you don't want to see? In a database, there is this beautiful thing called select, where you say, like, this is the old world of CAP, and then I'm selecting it onto unicorns and rainbows. Like, I just want to select the price and I want to name it price as opposed to product price or something. Like, you just want to translate it. So you can do that over here as well. You can say input, it doesn't tell me anything. I still need to fish out that text out of the text box. Let me actually create once and for all something that's really what a text box ought to be. I will say from I don't freaking care what this thing is in input, from underscore and input, because I'm not even going to dot into it. There's nothing to be found in there. Select, txt.text. Beautiful. What I have now, in result, is an observable no longer of event args and senders and blah, 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 blah. What I have now is an observable string that I could pass to somebody else, right? Somebody else says, like, if you give me changes to strings in a certain place, I can do something meaningful with that. Maybe I can do some analytics on top of that. Like, I know how to write that library. Just give me an observable string, right? So now you can do that. You have your text box here. You're projecting it onto an observable string. So now that I have this, I could set a breakpoint over here and just show you that this thing actually does something. Like, I set a breakpoint in the handler, and over here I'm actually typing R, and there you see, you basically get E passed into the handler that says, the value that the user typed is R. I have an I observable that calls me back whenever the user types. So that's nice, that's nifty. Now, the beauty is, of course, you can do more than just projections, right? Like, what if, and this is the typical flow of this little demo, but like it's still worth to point out also with like the disposable logic behind the scenes, I will talk about it a little bit. If you want to feed this into a web service, what's the problem with that data sequence? The user is typing a reactive or ping or bang or whatever, like he's typing a long string. Like, if the user types reactive, it types R, R-E, R-E-A, blah, blah, blah. When you type R, do you really want to download the whole dictionary? Likely not, because the user hasn't finished typing yet. And UI designers tell me, don't introduce a button just to force the user to make sure that he's actually doing something. Like, buttons are forbidden in the brave new world. Like, you know, you need to type and it needs to be smooth and it needs to fall out of the ceiling and beautiful and this and that. So you don't add a text, you don't add a button here, but you still want to have the user just type and go to the web service when the user is done typing. How do you know when the user is done typing? The answer is you need to run some timer. Whenever the user presses a key, you run a timer, and when the timer elapses and the user hasn't typed in the time window of that timer, it means that the user actually stopped typing and we can forward the message to the web service. That kind of logic, right? Like, that's pretty complicated to get right, because then the user types again during that timer. You need to dispose the current timer, start a new timer, and the whole thing starts all over again, and maybe you have disposed timers. Maybe your timers weren't rooted in the CLR, which means they get garbage collected and the timer never fires, like lots and lots of things to actually keep track of. So, in Rx you just say, well, you know, I have this event sequence sitting here. You know what, I actually want to throttle it over here. I want to say, throttle this thing based on a time span of half a second. Which means I have an observable of string, now I get a new observable of string that when you listen to that thing, and the source observable is actually producing values, it needs to take at least 500 milliseconds between two events before an event is propagated. So the user is typing reactive and he's really, you know, typing really fast, and then he stops typing, and you know, it takes like more than 500 milliseconds before he types again. Maybe he never types again. He has reactive in that text box. Now reactive actually is propagated to the web service because the user stopped typing, the timer elapsed. We do all the resetting of timers for you, of course. So as I have this thing here, this is really like a little game of sort of trying to break into the debugger at this point. I have still my breakpoint set in the subscribe handler. Let me actually type F5 and try not to see Visual Studio by typing really fast. See, I'm just typing over here, you know, reactive, and you know, I didn't hit the breakpoint yet, but now I stopped typing for more than 500 milliseconds and the event was propagated downstream, like to the downstream observer. So you see the total actually had the effect of holding on to an event till the user doesn't type again. Now there's of course more you can do, and in fact I will explain this in the slide later on. There's this thing called distinct until change that you can add as well. What does that thing do? If the user types the same thing twice in a row, you know, you don't want to go to the web service the second time because you've already gone to the web service and the dictionary doesn't change that often, people tell me. So there's no point of actually making a second web service call. So in this case, the user types reactive, it propagates to the web service, and then he starts correcting that thing and type reactive again. He leaves his hands on the keyboard. Like, there's no need to refresh the input because, like, well, it's the same input as we had before. So let me actually try to trigger that one as well. So let me actually show it without it first, like without the distinct. So here we go. Like this. So that's without the distinct. I'm actually typing over here. Reactive. Okay, wait for 500 milliseconds, the breakpoint hits. That was reactive, that's beautiful. I press F5. Now I'm going to change my mind. Bang, no, I want to search for reactive again. The event fires again, but nothing has changed really. Like, we're going to the web service again with reactive as the input. We don't want that to happen. So what you can do in that case is you say distinct until changed, which means hold on to the last value. When a new value comes in, compare it to the last value. Like, UI stacks don't do that. UI stacks don't say, like, Word doesn't do that. Like, Word doesn't say, you know, I don't want to render this document as, like, not edited unless the user has really changed something. To do that, that would be really, really bad. That would mean have a copy of the whole document sitting in memory. When the user types something, make sure the user doesn't type something that's the same as the previous document. Like that's comparing like 50 megabytes with the next 50 megabytes, blah, blah, blah. Like you don't want to do that at the bottom of the system. But in this case, it makes a lot of sense to say, I want to have distinct values. I will have a copy of that string sitting somewhere so that I can compare it to the next value. So that's what's going on here. Let's press F5. And so let's try this again. I'm typing, whoops. Okay, so that was a weird input. You know, I took my hands off the keyboard a little too long. But so I'm typing reactive here. Oh, I disabled the breakpoint in doing so. Okay, so the whole demo went to flames. Let's do it again. So we're back here. I type reactive. Okay, it was reactive without an E. Okay, remember that? Like I did mention or managed to actually get the E in. So you see, reactive is actually what came out. We're doing a web service call at this point. Oh, and now there is reactiver, because I was actually typing at the point the debugger broke. Like, you know, this is not the best way to show this thing. But so I have reactiver, okay? So reactiver is really a beautiful word. And now I want to correct myself to search in the dictionary for another word. Let's search for Bing. No, let's search for reactiver again. Oh, you see, like I typed reactiver, I waited for 500 milliseconds, but the input is still the same as what it was before. The event didn't get propagated to the system because it's the same as the previous reactiver. So I can correct this with reactive, and now, of course, I'm going to the web service. That's beautiful. Now, when I go back here, I'm back into the application. I had reactiver, which I searched for. Then I had a false positive, which I didn't search for. Now I have reactive, which I searched for. Let's actually search for reactiver again. It fires again. Why is that? Because it's distinct consecutive values. It's distinct until changed. I could also do distinct, but then I would have a dictionary look-aside kind of thing that said, what was the result of calling reactiver in the dictionary, that kind of thing. So in this case, it just filters out adjacent duplicates. Like twice the same thing, filter it out. In fact, with Kinect, we're going to see exactly the same thing. So to wrap up this demo, what I want to do is I want to go to the web service whenever the user types. And there is something interesting new happening in RxT2 for those of you who've seen this before. For those of you who've actually seen the demo before, there is something interesting to mention here. Before I go any further, this from event pattern had to change quite a bit in RxT2 to actually work with WinRT. WinRT is this new runtime on which Metro is based, the Windows 8 Metro. Actually, .NET events and Metro events share the same metadata. Like, you know, in fact, like WinRT files, WinMD files, have the same metadata specification as the CLR. So you can actually ILDESM a WinMD file, which is like one of those Windows runtime files, and you can just look at everything. Just doesn't contain IL code because it's not implemented using IL, it's implemented using native code. But so it shares the same metadata. So you don't have IDL files, header files, blah, blah, blah. Like those are the things you want to forget about, so we have the same metadata format. So events share the same metadata format. Now what does the CLR spec say about events? It only says an event is really an add and remove method. The signature about those things is not prescribed anywhere. Like it just happens to be that the common language specification says for events and VB and C# and F# and this and that, they need to look like this. The add method takes in an action, returns nothing. The remove method takes in an action and returns nothing. Like that's the symmetry in .NET events. You give it a delegate, it gets hooked up. You give it a delegate, it gets unhooked. That's add and remove. Very simple system. Now, being a native world, like in WinRT, you know, Win32 people don't like to remember the thing that was passed into one operation to get rid of the second thing, right? Like, if you do open file in Win32 for foo.txt, to close the file, you don't have to say foo.txt again, right? Like, they don't like that kind of symmetry, because then they need to have mapping tables. So they have once and for all solved the problem of mapping tables by introducing handle tables in Windows, in the Windows operating system. To do open file, you get a handle, you do close handle, only one close method called close handle, given the handle, right? So it's asymmetric. You add something, you give it some data, you get a handle back, that's the thing you remember. Looks a lot like Rx, by the way, right? You give it an observer, you get a disposable. The only thing to remember is a disposable. Then you can get rid of it. So it's a very sort of fluent way of doing things. So they changed the way they do .NET events. Well, not .NET events, WinRT events. They say the add method takes in the delegate, returns an event registration token, the remove method takes in the event registration token and returns void. Rx had to change to make sure we can talk to .NET events, which use the symmetric pair of add and removes, and to the asymmetric world of WinRT, where they use a kind of close handle mechanism. So from event pattern here, even though your code hasn't changed compared to WPF, Silverlight, Windows Phone, and all of those things, it's actually doing slightly different things under the covers. So that's just one thing that I want to throw out here. And in fact, like if you're an IL junkie like I am, and you're sitting on a plane or a train or something, and you don't know anything to do, just write a little piece of C#, and you go into IL Desm and you look at the wonderful world of the IL code generated. Like you will have a lot of fun in .NET 4.5. Like the way events are done is slightly different, the way iterators are done is slightly different, blah blah blah. Like there's a lot of interesting stuff. So in fact, like if you do txt.textChange plus equals this kind of code in C# 5.0, if you do it on WinRT, the code generated will be slightly different from what it used to be in .NET. So, what was I saying? Okay, that was a long detour. Okay, web service call, beautiful. So we go back here, and I was actually searching for the web service. That's this guy. It's just a very simple service. And I can go to that service and ask, like, give me the words that start with a certain input, right? So if I type React, I want to get reactive reactor and all of those kind of things. So I want to import this guy into my Metro app by doing add service reference, discovering this service. Here we go. And when I go to the advanced tab, you will already see the first thing here. At the top, you see allow generation of asynchronous operations. Those of you who've seen this dialog before will notice two things. In .NET 4.0, this thing was just a checkbox. It didn't have radio buttons underneath it. So you couldn't select whether you want to have task-based methods or asynchronous operations. They call it over here, which is really a weird name because allow generation of asynchronous operations, give me asynchronous operations. I need to talk to the UI people. This doesn't make a lot of sense. But so the second thing means give me the standard begin and invoke pairs. Begin lookup in dictionary and lookup in dictionary with async result, async callback, like all that, like dancing around and doing rain dances, right? Now we have this new thing called task-based asynchrony, which is the way we actually want to standardize all the async stuff in the .NET framework with very nice language integration in C# and VB called async and wait. So that's the first thing that has changed. This is the new preferred way. The second thing that has changed, because I'm in Windows 8, this thing doesn't even allow me not to generate asynchronous stuff. In fact, you won't even get synchronous stuff. You only get asynchronous methods in Windows 8. Why is that? Because they don't want applications, those nice, immersive, full-size, Metro-style applications, to hang ever. They say, everything that can take more than 30 milliseconds, forget it. No synchronous API, just an asynchronous one. We'll get some muscle here. Like, all the developers need to do asynchrony there. And it's fortunate that like in Rx it's really easy to do, as well as in C# 5 and VB11. So I was just talking about something you can't change. Okay? So just live with that. I'm just going to click the OK button. So here we go. Now we get our web service proxy being generated over here. And I can do something like var service equals new service reference 1, which is a beautiful name. Create a new dict service SOAP client, which is the generated proxy. When I go to service, and I will actually scroll up a little bit for the people in the back, when you go over there, what you see is like there are no synchronous methods anymore. I have a define async. There's no define without the async. There's a define and dict async, a dictionary info async, blah blah blah. Those are all the methods you saw in the WSDL, in the WSDL file. So I can do something like match in dict async. If I give match in dict async some inputs, it will give me back, as you can see over here, a task of dictionary word arrays. So it's no longer a begin end pair, it's actually something, just one single method that returns a task. And that task will actually signal when the web service completes. They'll say, here are your words that you asked for, or here's the exception that occurred. So it's actually an object that represents the eventual completion of an operation. So I can do something like match in dict wordnet, that's just the name of the dictionary. I want to search for React, and I want to use a strategy called prefix, which means give me everything that starts with React. That's just the way the web service is implemented. Like, that's not Rx specific, of course. But so this is the thing I want to substitute for whatever the user is writing. So this looks nice. How can I actually embed this thing in my query is the next question. Let me actually do some rename operations first. Result is not really result. Result is terms. That's what the user is writing, right? So when the user types and he's sort of silenced for more than 500 milliseconds and he doesn't type the same thing again, we'll actually have a new term. Now what I want to do is I actually want to really get results, which is from term in terms. I want to go to the web service. What am I going to do here? I'm going to do a join between my database of text, which is the user typing. Like, you have to think about this as really a join. User is typing. Whenever the user types, I want to look up in a different kind of table, and that table is a web service. In this case, I want to look up something. We already have join syntax in C#, right? We have multiple from clauses. You can say from term in terms means whenever there is a new term, do something, I want to look up in the web service. How do you do that? Another from clause. You say from words in, and now I will do this. Service match indict wordnet react of term prefix select words. So what does this mean? This means whenever the user types a new term, I get a new term. I will actually call this piece of code over here, like I will do match indict for that term. This will eventually, in the future, give me the words back that come from the web service. I'll return the words. So what this is we start with an observable of string, which is the user typing. Then we have something that takes what the user types into a task of dictionary words. And now I join those two things together. What I get back is an iObservable over here of dictionary word arrays. Whenever the user types, eventually the words are going to pop out. Okay? And now I can actually bind them to the UI over here. Now, the ones who've actually seen this demo before will notice like there's something weird going on here. Like match indict async was returning a task. Let me talk about it in just a second. But so I have the results coming back, which are now word arrays. Let me actually try to bind it to the UI. I can just do item source equals words over here, and we'll actually see what this actually gives me. So let's actually go and press F5 on this guy and see what happens. So I go here, I type react over here, and ultimately the web service hopefully comes back. It's not at all what I expected. Well, maybe eventually it will come back. Yes, that's actually the next part of the demo. But okay, it came back. It came back. You know, the web service was slow, so that's why we need asynchronous, right? Like the web service was slow. So, well, it doesn't look ideal yet. You know, this doesn't look like something that's in a dictionary for human beings. It says RPCE wrong thread, which is not a word in the English language, so this is not coming from the web service at all. What's really happening here is that my callback happened when the web service completed, which is on a thread pool thread. On a thread pool thread, you shouldn't change the UI. We all know that, and people already have the band-aids in their cabinet, like they have a cabinet next to them and they have thousands of band-aids. Like, I made a mistake again, put a band-aid on it. Like, the band-aid is called dispatcher.begin invoke or dispatcher.invoke or blah blah blah. Like, we don't want to do that. Why is that? Well, because in Rx we have an observable sequence, right? This observable sequence is like this marble diagram that produces messages. Where are the messages happening? They happen on the thread pool. How can I create an observable that is actually better behaved for me? Where the marbles are actually being produced, the messages are being produced on the UI thread. Like, didn't you say that observable sequences are objects? So couldn't I write a method that says, I have a bad observable that produces messages on the wrong place? If I tell it what the places where I want to receive the messages, couldn't I create just a new observable that produces the messages in the right place? The answer is yes, composition to the rescue. I don't want to go in here and write imperative code. Like, I'm not crazy, I'm not going to do dispatcher.invoke or dispatcher.run async, it's called in WinRT. Like, I don't want to do that. Instead, what I want to do is result. This is happening on the wrong place. I want to do observe on the dispatcher. which means I have an iObservable of t. The t's are being produced on the thread pool thread or in La La Land or wherever, but I want to see them on dispatcher. Please give me an observable that when I subscribe to it, those messages are received on the UI. So I can just do observe on dispatcher, all problems are solved. So in fact, like, this is very important. If you get this whole piece of code, going back to, like, you know, the first class nature of Rx, this whole piece of code might be defined in a different assembly altogether. You may just get like an observable of dictionary words. That's from the guy who knows everything about WCF, and you said, like, I know how to render this in the UI. I'll just give you, like, when the user types something, that's an iObservable of string, and you will give me an iObservable of dictionary words whenever something happens. And you will do all that WCF plumbing. You will create SOAP headers and this and that. Little do I know that he just right-clicked and generated a proxy, but like, he wants to sound smart, and he says, yeah, I will take care of that. That takes 3 weeks for me, but then you will have a function from iObservable of string to iObservable of word array. And then you get that thing back, and it doesn't happen in the right place. What do? You just say, I'm already prepared for this guy giving me results on the wrong place. I'm going to do observe on dispatch. It's always going to be in the right place. That basically means when the message comes in, transfer it to a different thread to produce or execute the rest of the code, which means this piece of code. So as I execute this, it will actually work. Little do you know. Here you go. I type React. Hopefully the web service is a little faster. Okay, this looks nice. This is just a toString of the generated type from the web service. Like, that's just like some more dancing around in order to map that onto the right thing. You already know how to do that. I got words back here, which are dictionary words. Dictionary words are the generated type from the web service proxy. You know, I just want to get the thing that's inside of those guys. Like, why are they doing this? Well, if I do words 0 and I dot into it, I could search in multiple dictionaries. So they're actually telling me what the dictionary is they found the word in, and they're also telling me the word, which is a system.string. They're giving me slightly too much. I don't want to have all of that stuff. I just want the words, right? So we all know that that's just an array, and we know how to deal with data processing on arrays. It's also called link. So I can just do from word in words, select word.word. Okay, looks a little funny, but you know, it's just link, right? So here we go. That's just projecting dictionary words onto the words that are inside the dictionary words. And so now I can type reactive or react or reacty or reacty. See, it's actually working. You know, I was typing reactive, and there we go. We actually get the words in the dictionary that start with the input of the end user. So we've done all of that stuff using observables at this point. There was just one little thing in here that I didn't talk about yet. This thing returns a task of t. That's not an observable, is it? It isn't, actually. It doesn't implement the interface. However, the syntax that you have here, from select, C# doesn't care where it finds the corresponding method. It just says, I need to find a select many method on this thing, on terms, that sort of type checks. Like, you know, it needs to have all the right things in place. So what we did is we added an overload that says, if you put something that returns a task over there, we can do all the hard work for you. Why is that? Because a task of t is something that ultimately gives you a t, right? Like a task of string is something that will give you a string in the future. In fact, at some point in time, task of t was called future of t. So in the future, you get a t value back. This is really like an on-next call, right? Like telling you, here's the t. Maybe something went wrong. Tasks also have the option of something going wrong. Then they tell you, here's the exception that actually went on. That's like an on-error. So this really looks like an observable. In fact, it's a special case of an observable. A task of t is an observable with a single value inside of it. It doesn't implement the interface, but it's implicitly convertible to it by having this kind of overloads. So we said, let's put those in place because the BCL is full of those guys. Like, everything will be like, you know, based on those async methods. So you can just write a fluent syntax. Okay, let's actually switch back to that one. Welcome back. We just saw how to do like the dictionary suggest demo, so which actually shows some of the capabilities, including how to convert events into observable sequences using from event pattern. We saw how to deal with asynchronous methods, which are just returning task of t, and you can actually convert those as well.
So those are some of the capabilities, and we'll actually see those come back later in the demo as well. But now let's actually talk about some other queries you can actually write. So the query we looked at was basically just doing a join between two sequences. You can do much more advanced stuff than even that. And so here's an example of doing stock trade analysis using RX. That actually happens to be the case that there are quite a bit of people in London and New York that actually are using it in the financial industry as well. So this isn't too far-fetched as an example. So what I have here is an observable sequence of stock ticks, okay? And it basically tells you, like, you know, MSFT is trading now at 27.01, Intel at 21.75, and so on and so on. Now, what I want to do is I want to convert that sequence into a sequence that will tell me when the stock price for a certain company went up more than 10% compared to the previous value. So I actually want to see if those are the day closing prices. At the day the stock closes at an amount higher than 10% of the previous day, I want to have an alert in the system. Okay? So I can just do that using 5 lines of link. Let's actually take a look. So the first thing to do is I want to segregate this stream or partition the stream based on the individual stock codes. I want to say I want to have a stream for MSFT, I want to have a stream for Intel, and so on and so on. So the way to do that, we actually already know that from link to objects or link to SQL, is by doing group on. You say I have something of T, and I will basically partition that based on keys. So I need to give it a key selector, and then I get a stream of streams. Okay? I get a stream, the original stream is a stream of stock codes. What's happening now is I'm projecting it onto a stream of groups. Every time there's a new stock symbol, I get a new group. What's inside the group? It's by itself a stream which contains the values for that group, right? If you do a group by in SQL or like in link, you basically get an enumerable of I groupings, and I groupings contain a key and are I enumerable by themselves. So you get like a stream of streams, a sequence of sequences. So that's what's happening here. I'm saying from tick and ticks, group tick by tick dot symbol. Now I get an I observable of I grouped observables of stock ticks, which basically, this new stream, which are those 2 lines combined, basically tells me when a new line is born, when a new symbol is observed that we haven't seen before. So the first time we see MSFT, we say, hey, we noticed a new stock symbol here. Let me give you a stream that you can listen to in case you're interested in MSFT stock. Then Intel starts trading later on. We give you a new stream that says, here's a stream. If you listen to that thing, you will hear everything about Intel. So at the very first observation of a new key, a new stream is born. And then inside that stream, we just project values that belong to that particular key. So now I basically have a stream of 2 streams. That's nice. Next, what I want to do is I want to compare 2 adjacent values in those streams to notice like increases. I want to compare this value to that value, that value to that value, that value to that value, and so on. So how can I do that? Well, I have a stream of points here. What I really want is a stream that combines 2 points into little lists or something that I can look at the individual values. So I want to buffer those 2 guys up and look at them both at this point in time. That's the closing of the second day. I want to see the closing of day -1, the first day, as well as the current closing to compare the 2 values. Then I want to do the same for the second and third day, the third and the fourth day, the fourth and the fifth day, and so forth. So how do I do that? We have an operator for that. That's sort of like a t-shirt I need to print. We have an operator for that. That should be buffer. Buffer says, give me an I observable of T, and tell me how you want things to be buffered. I want to buffer them in groups of 2, and I want to skip ahead with 1 every time. Which means, give me Monday and Tuesday, Tuesday and Wednesday, and so on and so on. So it's 2 days, and actually skip with 1 day every time a new buffer is created. So you actually get 2 consecutive days. If I would do weekly analysis, I would say buffer 5,1. Assuming there are no observed holidays or real days that fall off the cliff there, that would actually be Monday, Tuesday, Friday, well, Monday to Friday, let me put it like that, instead of like citing all the days. Monday to Friday, then Tuesday till Tuesday next week, because there are 2 closing days in the stock and so on. So you would actually hop with 1 value, and you would actually get the 5 last days at the time. I could also do buffer 5,5, which would be, give me the buffer for the first week on Friday, give me the second week the next Friday, the third week the next Friday, and so on.
So that would be skipping ahead with the same amount of values in the book. So now I have this. I have lists over here that contain the two values. What can I do with that? Well, obviously, I could do something like get open close 1, which is the second value, subtract open close the first value, which is the difference between the 2 days, divide by the first day. That's my percentage of change. Just a little bit of arithmetic here. And now I get a stream that for every second day it looks at the previous day and actually tells me what the increase was. 3.4%, 10.4%, minus 1%, and so on and so on. So now I have streams of changes. Okay? Next, I want to have a where clause that says I only want to have the differences that are larger than 0.1, more than 10%. Okay, so there is one that's more than 10%. And finally, whenever that happens, I want to select the company.key, which is the key of the stream on which that value existed. So 0.104 lived on MSFT, as well as the increase value that I computed. And now I have a stream that whenever that event occurs in any of the companies, will tell me MSFT close to day 10% higher than the previous day, 10.4% higher. So that's like how many lines? That's 6 lines of link code to basically do that on event streams. Now you subscribe to that thing, and you just have your thing that tells you buy or sell kind of things, right? So, really simple way of making money using RX. Well, typically it's too late. You know, that's the only problem with like stock trading. You get to know when you should have bought in the past, and so that doesn't quite work in general. But like, that's apparently what people make money from. So instead of doing stock streams, I'm not really a stock guy. Let's actually do some complex event processing using that other thing here, which is a beautiful source of events. It's called Kinect, right? This is a source of skeletons. It sounds a little bit weird, but it really is. In that, you know, this thing gives me 30 times a second a skeleton, or multiple skeletons if there are multiple players, as well as pictures, depth frames, and all sorts of things. So let's actually take a look at how I could do RX to detect my hand moving, for example. So I have the Kinect SDK here. You can just download the Kinect SDK. You just need to have a Kinect and a good cable. And then you get this kind of funny thing. You have a tilt angle, which is like how much the Kinect is tilted, so I can actually move it. There's a little motor in there. And I have a color stream, a depth stream, and a skeleton stream. So when I actually move in the picture here, you see there is a skeleton, right? So those are all the joints that it's basically tracking 30 times a second. It knows where my left hand is, where my right hand is, my head is, like everything. And so now you can do Dance Central, of course, using that thing. I'm not going to try to do Lady Gaga impressions here. I do that in private at home. So. And so you see it's doing that at 30 frames a second. So now what I want to recognize, for example, is like the player is moving his left hand, for example, more than 5 times a second, meaning the user is waving at the Kinect. Like that kind of thing I want to process. So let's actually try to do that. Let's close down the Kinect sample here and just create a new project. And obviously, all Kinect demos start with console applications. Console application 9. I'm not going to draw skeletons or things. That's just like, that's UI fluff. I'm not doing that. The only thing I'm going to do is I'm going to do some console write line when the user is shaking his hand, right? And you can imagine the nice picture coming up or like, you know, something starting to happen. So let's actually include not Microsoft Expression prototyping. What was I thinking? I don't even know what it is. Let's include Microsoft.Kinect, which you get when you install the Kinect SDK. That's nice. And let's include System.Reactive as well, where there are now 4 assemblies, which I will talk about on a separate slide. System Reactive Core Interfaces and Link, which are the 3 layers you've actually seen in my architectural slide, and something mysterious called Platform Services. This allows us to be portable across multiple platforms, and I'll talk about that in a slide actually. So that's just RX. This is because I'm using a .NET 4.5 app, not a Windows 8 app. I don't get this nice, you know, extension SDK model just yet. Like that's only for Windows 8 Metro Style apps. You can right-click and say, give me all of RX. I could also do right-click, go to NuGet and say, give me all of RX. That would be the same thing, but you would still see like 4 or 5 things in the reference dialog. So they haven't changed that. So now I can actually go to Kinect by doing, I believe, Kinect sensors. No, Kinect dot. Kinect dot. That's nice. Microsoft.Kinect. And now I can actually try to get the sensors by doing Kinect sensor.Kinect sensors.single. Because actually Kinect supports to have multiple sensors per machine. So you can actually have sensors that are basically in a circle or something, so you can track the whole room, you can track people moving from one sensor to the other, like all sorts of fancy stuff. So they support multiple sensors on a per app basis. So I'm just going to do Kinect equals Kinect sensors.single, which means I assume there's only one connected. Let's do console.writeLine of Kinect.SOMID, the device connection ID, and let's do console readline at the end to make sure my app doesn't die, because it's asynchronous, right? I don't have a UI loop or anything here. And finally, let's actually do Kinect.start here to make sure it will start receiving data. And over here, I will have to do some to-do, of course. So as I run this, it should just show some beautiful looking ID, which is my device ID of the Kinect being connected to the system. That's just some diagnostics, and that also makes the demo cooler to have something we don't understand. So, good. Next, what I can do is I can walk up to the Kinect sensor and say, you know what, I want to get some data of, for example, color frames. Please give me pictures every time the picture changes. Give me depth frames, how far the users are. Give me things like the skeletons over here, the skeleton frames, and so on. So let's actually do something with the skeleton frames, just by using a .NET event, and of course you can already guess this will change into an RX query in just a moment. And I will do Kinect.skeletonstream.enable to actually turn on the skeleton stream. They don't want to allocate things if you're not interested in them, so you have to do a little bit of manual plumbing over here. Let me actually combine that together, which is my initialization code and so on. So now I have skeleton frame ready over here. Let's take a look what's inside my event RX. Be prepared to be amazed, as usual with event RX. It derives from event RX. It doesn't contain properties. It contains a method. Event RX with a method. We haven't seen that one before yet. What does that thing do? It says open skeleton frame and it gives you a skeleton frame. So you basically walk up to the event RX and you say give me a skeleton frame. This thing, this skeleton frame, contains useful stuff, of course. It contains things like the floor clip plane to actually do some analysis, frame numbers, timestamps, all sorts of weird things. But let's actually talk a little bit about this. It returns an iDisposable, or it implements iDisposable. Why is that? They're basically wrapping a native API. They're putting things into a buffer and so on, and you have to tell them when you're done using the buffer. And you have to actually tell them that you're done using the skeleton frame buffers that they allocated internally within the 30 milliseconds of receiving it, because they're going to jam things into the same buffer. They don't want to have things like, memory managers kicking in and sort of like throwing off the whole steady frame stream that they actually have of 30 times a second. Like if things are taking a little too long, more than 30 milliseconds, and in fact like scheduling timers, for example, in Windows NT are 15.6 milliseconds, like you can only afford one of those to happen, like for an interrupt. Like if those kind of things are happening, like you're totally host. So they say you basically get the frame, you get the data out, and then you dispose, which makes it really kind of a little bit ugly to do classic .NET event processing on top of that. Because next what you want to do is you want to look at the frames over a 1 second window, which means you have 30 frames that you want to buffer up. You can't leave those frames open because they're going to overwrite them, like they're going to use some buffer. So you have to copy them out and then keep track of them. So like there's a lot, you can already see it, like if timers are involved, you have copy operations, you have using statements that are in weird places because you need to make sure this thing is disposed. Like it's not the best experience, but it's actually the most performing experience at the bottom of the stack. So I want to make this a little bit better, of course. So let's start by making it better. Well, let's actually start by actually doing console writeLine or something over here, just to show that I actually get some skeleton frames over here. So just console write of dots, and like I'm standing here and I see just dots, right? That's my skeleton being tracked 30 times a second. The dots, of course, need to be a little bit more meaningful. In fact, it's still tracking the non-existence of skeletons at this point, which it also does. It just tells you there is a new frame ready. It just doesn't happen to contain any skeletons. In fact, let's now try to get into the world of Rx here. Instead of doing this, I want to take that into an observable of skeletons, and then I can start manipulating it using time operations and all of that. So I'm going to say, I don't know how it should be called yet, let me call it axis, like we'll see how we transform it over the course of time. So observable dot from event pattern of skeleton frame ready event arcs. That's the event arcs type. And we've already seen one way of getting this thing before. I could actually say connect, comma, skeleton frame ready. That's one way of actually getting to that event. Okay? That's using reflection. When you subscribe, we try to find the event, we try to find the add method, we hook up a delegate and we give it to the event. That kind of stuff. Now instead of doing this, let me actually show you another overload. Let me show the overload where we ask you to tell us how do I hook up to the event, how do I unhook from the event. So you have to give us a pair of actions. When the user subscribes, we need to hook up to the event. When the user disposes, we need to unhook from the event. If you tell us those two things, we can create a bridge, right? And so this looks like this. Handler goes to, we give you a handler, you hook it up. That's the first thing. In fact, it's called add handler. The first parameter is add handler, and we give you a handler called handler, and you would have to hook it up. So that would be connect.skeleton frame ready plus equals handler. Okay? Then we need to have remove handler over here, where you are given the handler that we cooked up, and you need to get rid of it. You do that for us. Like, we don't know how to talk to the event, we've never seen the event, you need to do some wrapping. So this is the alternative way of actually using from event pattern, is by basically giving us a minus equals and a plus equals. It's a little bit of a pity there is no syntax to capture a delegate to plus equals and minus equals, because those are hidden methods that the compiler generates. But so this is really what's going on. When the user subscribes to this thing will be called, you hook up the handler. When you unsubscribe or dispose, this thing gets called. I'm just making this a little bit more explicit here, using C# 4.0 named parameter syntax. So I just get some documentation for free here. So different ways of doing this. This is just one way. Okay? The beauty is, like, at this point we're in the observable land, we don't have to care about plumbing anymore. Well, just a little bit, because Kinect sort of has this weird disposable thing, right? So if I look at axis and I subscribe to axis, I could say whenever there is a new skeleton frame, I can do e.eventarcs.open skeleton frame. I could totally do that. I could just write some imperative code here to get that skeleton frame. Let me take a look at what you have to do with the skeleton frame, right? You assign it to something called frame, then you walk up to the frame, and now you can suck out things like the floor clip plane, the frame number, the timestamp, the tracking mode, and all those kind of things. You can also get here, as you can see, the skeleton array length, as well as all the skeletons. Copy skeleton data too. So you can copy the skeleton data out of the buffer into your own allocated object. So that's the typical thing you do with this guy. Let me actually show you how you would do that. You would actually say var skeletons equals new skeleton. What's the length? How many skeletons are there being tracked? Well, let's do frame dot skeleton array length. They tell you how many skeletons you have to provide room for. And now you can say frame dot copy skeleton data to skeletons. So you basically put them into that array. That array can now outlive the current call frame, because like you've copied it. Because they want you to actually do this. They want you to close the frame as soon as you're done with that. So that's really the kind of thing you have to do. But then next you have to do something like, now I'm in this event handler and I want to buffer things for like 1 second or something. I better have a field sitting somewhere with a list of skeleton arrays that I add to every time, and then a timer that actually fires every second to swap out the list for a new list and take a look at the previous list. Like, your head explodes at that point. So we don't want that to happen. What we want to do is we want to turn this skeleton frame ready event arc stream into a stream of skeletons. And then I can do some processing on top of that. So instead of doing a subscribe and doing all of this voodoo over here, why don't I just project it away? I don't want to see all of this state management anymore. I just want to have an IObservable of skeleton arrays. Yes, I'm going to allocate skeleton arrays every single time. That's fine. Because I need to look at them anyway based on time. I will have to copy them. So I'm gonna say var x's, let's say var y's equals from x in, and let me actually give it a good name now. This thing is called frames. From frame in frames, and this thing will return skeletons. From frame in frames, select, and now I need to do that whole dance there to basically copy them out. Okay, I will use other syntax here. I will use the non-embedded syntax. I will do frames.select of frame goes to, and now I can copy this whole piece of code in here, and over here I can do return skeletons. What do I have now? And let's do skeletons over here. If the whole thing is happy here, it's not happy yet. Oh, I have frame multiple times. That will be interesting. Skeleton frame, SF, also stands for science fiction. Okay, here we go. And now it's happy. Is it happy? Skeletons is already defined. Where do I have that defined already? Oh, over here. Ah, yes, yeah, the scoping rules. Skeleton array, SA. See, your code gets shorter when you use Rx. So what I have now is I have this stream of weird skeleton frame ready event types. Now I'm projecting each frame onto, open the skeleton frame, copy it to an array, return the array, and dispose the frame. Now I have a stream of skeleton arrays. That's nice. I can work with that. I can forget all of that stuff. I can put it in a helper class or something that just returns iObservable of skeleton arrays. Like, you just write this thing once, you don't have to think about the dispose anymore. Because dispose used to be the sword of Damocles, right? You're sitting in your event handler, you're doing weird stuff there, and you forget to dispose that thing. Kinect will blow up, maybe the motor will start shaking or something, and it will do the unhappy dance kind of thing. I've never tried it. But so, you don't want that to happen. So, you can forget about all of the things on top here. Now I have my skeleton stream. I have my skeleton arrays. Let's take a look at what's in the skeleton arrays. Skeletons, 0. Let's just take a look at an individual skeleton, right? Oh, E. Well, let's call that skeleton stream over here, and then this thing are skeletons, and then I can get skeletons 0 and take a look at the skeleton. What's in the skeleton? The orientations of the bones. That's nice. Clipped edges. Don't know what that means. Joints, that's also good, like the skeleton joints, the position, the tracking ID, a lot of interesting things. Where's the player on the screen? Is he to the left or the right? Where is his center of his body? What are the joints? The joints take in a joint type array, or enum, and I can get like the ankle left, the ankle right, the elbow left, elbow right, like all of the joints that they're tracking. They're tracking like 20 joints per body they're observing. So I can actually get all of that stuff over here as well. So that's nice. There's maybe one more thing. It has multiple skeletons. It can actually track multiple players, right? If you do Dance Central with 2 players or like 4 players, like it can track multiple people in the picture. So how do I know that I'm selecting the skeleton that's actually being tracked? Because like, you know, you're dancing, you're sort of getting to sit in the chair. At that point, you know, skeleton 0 is no longer being tracked, or actually it has a tracking state of sitting down. It has actually states that see whether somebody's sitting or standing. At that point, I don't want to look at that guy anymore. But things don't need to shift, right? You don't want skeleton 1 now to become skeleton 0, because then you're confusing 2 players. Like, it's not because somebody's sitting that somebody else is taking over his job. So I actually need to take a look at the tracking state as well. I'll be the only guy being tracked here on stage, so don't jump up, please. And actually I will just select, or assume there is just a single player in this case. So what I really need to do is I need to go into the skeletons and get the single skeleton for which the tracking state is tracked. The guy is being tracked. Because I will get multiple skeletons for non-existing players that haven't entered the picture yet. So I need to get that one skeleton out. How do I do that? I use linked, right? I say like var tracked skeleton stream equals from skeletons in skeleton stream let tracked be skeletons dot single or default skeleton where the skeleton is being tracked, like this. So what I'm doing here is I'm basically saying get me out of that array of skeletons the single or default, like null or the single value of a skeleton which is being tracked. So this might actually 30 times a second it will say this is a skeleton being tracked, or it may be no. If somebody jumps on stage, I will have an exception here. Right? So I'm not thinking of multiple player games here. I could do that as well. Like I could take a look at a tracking ID and do a group by tracking ID to have multiple streams for each individual player, and then do processing on the individual players. Maybe they merge together again if they're doing a tango or something. Like, yeah, I never know. Right? So, where tracked is not null, meaning we're tracking the skeleton, I want to select the tracked skeleton. So now I have an observable no longer of skeleton arrays, I have an observable of skeleton, which may be null, or well, may actually be absent, or the single skeleton being tracked. So when I will enter the picture, there will be values for my skeleton. When I exit the picture, I will be gone. So let's actually try this. Tracked skeleton stream over here. Subscribe to that. Let me just call that S for just the time being. And let's do console write of exclamation mark, meaning something is being tracked. I'm not there. You know, that thing is returning null. The single or default is returning null. I'm entering the picture, I'm being tracked. Here's my skeleton coming at me 30 times a second. Now I could look at the joints and the bone orientations and all of that stuff. I exit the picture and Kinect doesn't see me anymore, the stream shuts down. It doesn't shut down, it stops producing messages. When I enter, at some point, we'll see the output. Come on, Kinect, don't fail me here. Like, it stops again. When I come back into the picture, it should catch up again. I don't know, maybe I need to move a little bit more. Yeah. Right. So there we go. It's basically recognizing me. In fact, it doesn't see all of my legs. So I think it is actually a little confused. Is that a human body? Is it somebody who's amputated his legs? That kind of thing. It's maybe a bad joke. Wasn't a joke. To him, it looks like somebody who doesn't have legs. Can I? Do I know anything about that stuff? Good. So, I have a tracked skeleton stream. What do I want to do now? I just want to get my left hand. I want to know where the left hand is and I want to do some shake detection or something. So let's actually do var res equals from skeleton s in tracked skeleton stream. Let's say let x be s dot. What can I get out of this thing? Oh, okay, s is a skeleton, so I can get the joints, the position, all of that stuff. That's nice. I can get a joint type left hand. Hand left, okay, yeah. Apparently it has to be written that way. So what I can do now is I can select my left hand. What's the left hand being tracked? What's a joint? It's a joint type, it's a tracking state, it's a position. In fact, in my particular case, with my legs not being observed, I would still be able to actually get my right ankle, my left ankle, my knee, and it would actually have a tracking state of not being tracked because I can't see it. Like, you know, that's only part of a human in the picture. In this particular case, I will assume my hand is actually visible and being tracked. So I will just get the position out of that. So what I now have is left hand position, okay? Now I get my left hand position stream, left hand pass, which is a stream of Kinect points, skeleton points, which have an x, y, and z coordinate. Can detect whether my hand is in the back, to the left, to the right, all of that. Like we're in 3-dimensional space, so that's good. In fact, we're in 4-dimensional space because we have the time axis as well. So let's do console write line over here of position.x plus, comma, position.y. Let's just do x and y for the time being, and let's actually see what happens. I'm not there, so I'm not being tracked, that's good. When I enter the picture, we should start seeing coordinates of my left hand. Okay. So that's my left hand, the x is on the left. My right hand doesn't have an influence, as you can see, like that's not interfering. And now if my left hand going to the other side, the coordinate becomes positive, coordinate becomes negative, coordinate becomes positive, negative. Hands up, that becomes really high, hand down, that becomes negative, because it's below my hip or something. Like I don't know where the zero position is of the body for Kinect. But so you see, like all the coordinates over here. I'm not tracking the z-axis in this particular case. So now, I want to detect when the hand is on the left of the body and the right on the body. So I just want to see when the user is trying to wave or something. So how can I do that? Oh, well, let's actually do something like var tracked equals from position in left hand position, where the position.x mat.absolute value of x is larger than 0.2. Like my hand is not somewhere sitting in the middle, my hand is really off center, to the right or to the left. right? So I'm just getting the places where my absolute position of x is actually outside the center. Let me actually select whether the hand is on the left or the right of the body. So let's actually select pos.x is negative. In that case, I will say my hand is on the left, otherwise the hand is on the right. So let's see, does that do anything? Type of the expression, type inference failed. That's not good. Oh, there is, I need to talk to Anders about this inner scoping thing. This is like, result, result is always good. When in doubt, use result. So there we go. And so let's actually print the pos, which is now a system.string. So I have a string that says left or right. Is my hand to the left or to the right of the body? So let's see. These are now, okay, these are good squigglies at this point. So I can come back here. Okay, my hand is on the left. My hand is on the right. My hand is on the left. My hand is on the right. That's nice. But now what I want is actually, I just want to detect the changes between left and right. I don't want to sit here 30 times a second knowing that my hand is on the left. I just want to see motion. Yeah.
Yeah, just a quick question. You do a lot of all the various sort of series of inquiries. Are those? I assume those queries are deferred until you actually subscribe.
Exactly. Yes. So the question is, when do the queries start executing? And so the answer is, at the point you do the subscribe, this whole pipeline comes alive. So no events are flowing until you do a subscribe. So it's completely lazily evaluated. So if I would take out this piece of code, nothing's really happening. Okay. So how can I actually get the times that my hand changes from left to right? We already know that if there is a string that says left, 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 and it goes to right, it becomes distinct. So I want to have distinct until change. I just want to see left. All the next lefts I don't care about. Then I see right. I will emit right. Then the user has right, right, right again. Then it becomes left again. Left is different from right, so we get left again. So we just want to see the points where this is changing. So I can just do this. I can say distinct until changed over here. Left stream, well, so lots of lefts, only the first one survives, still there is the first right, and so on. So as I execute this thing, I can stand here. Left, that's nice. My hand is still on the left, right? Like nothing's really happening here. But yeah, it's not distinct. Like it's not different from the previous time. But here's my hand on the right. So I see left, right, like, so that's nice. Now the only thing I have to do to detect shaking is basically buffer those things up with some time and see whether there were enough changes in a certain time window. So I can say something like, and this is actually left hand rel pos. I'm addicted to outlining, so you'll forgive me here for just a second. Like this. And now I'll say var result equals left hand rel pos dot buffer. Let's buffer those things over time spans of, say for example, let's say 3 seconds or something. Like, so now I get buffers that say the motions every 3 seconds they actually occur. Let's actually do a select of that buffer, which is all the positions or all the left rights that I've seen in that time, and count how many there are, right? Like in 3 seconds, how many left rights were there? So I can just do select of b goes to b.count over here, and then I could say something. Let's actually do this, where b.count is larger than, larger or equal to, it's the number of times I change my hand. Let's say 3 as well. Like, I think that's doable for a human being. So here we go, res, and now the position is not really telling me, well, the position is, it basically says left hand swinging. Okay? So now I get notifications whenever the left hand is swinging because it's happening more than 3 times in 3 seconds. So let's actually do that. Like, nothing's happening here. But now let's actually start swinging my hand. Okay, left, right, left, right, left, right, left, right. That's good. Yeah, it detected that there were more than 3 in that window. Like, there's another window in which apparently there were also events. Like, I would have to clip them a little bit more, but you get the basic idea. Like, I'm now looking at 3 seconds worth of hand swinging motions. Like, I'm not swinging at this point, so that's good. But like, as I start swinging again, this thing should become live again. Oh, there we go. So that was in 3 seconds more than 3 hand swings. So, and of course you could do more like intricate things, if Euclidean distance, blah, blah, blah. But so that's basically the idea. So you could actually buffer them in terms of positions. You could actually have every 3 seconds give me like all the positions the hand was in the last 3 seconds. And then look at that. Was the hand actually doing a circular motion? Because you actually smooth it on some line, and you see like in that 3 seconds, yeah, that was kind of a circle that the user was making. Of course, you will need some libraries that actually help with that, or you need to know something of how to do like this fuzzy matching kind of stuff. But like this takes care of like all the change detections, like with things like this, selecting out the right thing you're interested in, as opposed to having that whole sea of events, things like dealing with time. So a lot of stuff that's going on here. Any questions about this?
So what about aggregating streams? I mean, you have an if clause there, which is, if it's less than 0, it's left. If it's greater than 0, it's right.
Yes.
What about if I had a stream which is just my left events, a stream which is my right events? How do I aggregate them and detect that they're coming in, I guess, with a waving motion?
Okay, so do you want to have both hands stacked, for example, or?
No, it's like the select position dot x less than 0, you got left or right, so it's
Oh yes, yeah.
So I guess if you're on the left, you just want the event when you're on the left.
Yes.
I guess a stream which is just raising left events.
Oh, I see. Okay, yeah, you could.
And then a stream which is raising right events.
Sure. Yes.
So how do you aggregate those two into a single?
Oh, you would actually start writing multiple queries on top of this guy. You would actually say something like, likely you don't want to distinct at that point, or maybe you do. But like you could say like hand is on left equals left hand rel pass, where pass goes to pass equals left. And then you do the same thing for right, and now you have two streams that actually give you whether the hand is on the left or the right.
So that's splitting the stream.
That's splitting it.
And then how do you aggregate those two streams then back into a single stream?
So say you're doing some additional processing on both of them, right? And then at some point you have a common type again, you have like an IObservable of positions or distances or something you're computing, right? Now you want to aggregate the two streams you have. So you can do something like hand is on L dot merge of hand is on R, for example. Like so you can combine them again. So and of course you might want to do other things in the middle. In fact, there's one caveat here. In fact, it's interesting to bring that up as well. What's going on here, it reads a little bit weird here because now there's left over here, left and right over there, but what's going on here is this guy, when I subscribe to this guy, right, what's going to happen is I'm going to subscribe to hand is on left and subscribe to hand is on right. Assume, of course, there's some additional querying happening here, right, like you're doing some additional processing, and then you're merging two streams. But then if you look at those two streams, they actually both come from the same source. Now the gentleman in the front actually said, like, when do things get subscribed to? When do things start ticking? In this case, what's happening is, when I subscribe to this thing, I'm subscribing to the left and the right. When I'm subscribing to the left, I'm subscribing to where, which subscribes to its argument, this guy. When I subscribe to right, I subscribe to the where over here, I subscribe to that guy's argument. So it's actually bubbling up the chain, right? Like, somebody is asking me to subscribe to this thing. I need to subscribe to my sources, to my sources, to my sources, to my sources. So ultimately what's going to happen is all of this logic is executed twice now, because there are two subscriptions. The subscription for the merged left-hand branch and for the right-hand branch. You don't want that to happen, to sort of have duplicate processing, right? And so we have operators that allow you to sort of share subscriptions. And so that's actually called the publish operator. So this typical thing you have sitting here, what you want to do is you want to reuse this guy without causing multiple subscriptions to the underlying stream. And so what you do in that case, that's a little bit more of an advanced scenario, but like what you do is left hand rel pass dot publish of, and then you give it some symbolic name. Let me call it LHRP. That's a nice name. And then what you have here, this little piece of code, has an alias to left-hand rel pass that you can use multiple times to do whatever you want to do with that single subscription to the source. And then you can listen to that multiple times, do multiple kind of different queries on top of it, and then merge it together again. So what I would do is this. I would actually move all of this code into here. I would do a return out of that little island I have there, and I would substitute left-hand rel pass with LHRP, which is the alias. So what happens now is when you subscribe over here, when somebody subscribes to the result of publish, somebody subscribes to access, that is, we're actually going to subscribe to left-hand rel pass, and we're going to share all the events that come in into those little pipelines internally. So all those guys are seeing those events also percolating down, but there's only one guy listening upstream. So you really have this diamond shape now. You have a diamond shape that actually comes in like here. Here it splits into two branches, and here the branches come together again. And then somebody can listen downstream. Does that answer the question? Yep, okay. Good. So let's actually switch back to the slides and do a couple of wrap-up notes about the schedulers, which we haven't really talked much about. Actually, I need to keep an eye on the clock because all my clocks are out of sync. Like this is in the Brussels time zone, this is in Seattle, that's in Dublin, like it's confusing. So, we've seen a lot of cases where we're actually doing things based on time. We're doing things like throttle, things like sample I talked about, things like buffering. All those guys, like, they need to run a timer somewhere. Where does it actually execute all of that work? Like, if I'm asking somebody to buffer, like, which timer is being used? Is it using system.threading.timer? Is it using system.timers.timer? Is it using system.windowsforms.timer? Is it using system.windows.dispatcher.timer? Is it using system.windows.threadpool.timer, which is in WinRT? Like, a lot of those questions need to be answered. And so the answer is, well, we don't want to pick one for you. We are not the guys to say, like, you know, and you will always use the TPL, or you will always use the threadpool, or WinRT, or this or that. So we say, we want to abstract everything that has to do with executing work in the system using this common abstraction called an iScheduler. So whenever you see something and you look at it like observable.timer, where do those on-next messages happen? If you can ask the question, where do the on-next messages happen, and there's no logical answer to that, there will be an overload that takes in a scheduler. What do I mean, no logical answer? If you do something like where, access.where with a filter, where do the on-next messages come out? Likely where the source produced them and where we executed the filter. Like, we don't need to introduce some additional piece of work in the system. We just get the callback, we evaluate the filter, and we pass it on or we don't pass it on. So we're piggybacking on some concurrency there. But if you're doing things like a timer, messages have to be born somewhere. Things have to come into existence. And at that point, we have a scheduler-based overload that allows you to parameterize that stuff. By default, there are default schedulers. So typically, you don't have to see them. That's why when I did buffer or sample or throttle, you didn't see a scheduler at all, but it was sitting there. So what do you use that for? Two things. Here's synchronization. We already saw that before, just with a different exception. The new exception coming from WinRT with some ERPC long thread, which is really the same thing as the crop thread operation not valid, or you're calling this thing from the wrong thread. Like, there are many ways of saying the same thing. You're doing something in the wrong place. So what's happening here is I'm having a sequence called observable return 42, which is a sequence that when you subscribe to it, it calls your onNext given you 42. It's a single value sequence. It's one of those static constructor functions that we have. You can ask that question. Where does the message get generated? Who is calling the onNext? Who's raising the event? Like, I don't know, just by looking observable return 42. Is it a thread pool thread, a task pool? What's going on? I don't know. So those guys take in the scheduler. So here I say scheduler thread pool, which means spawn up to something like threadpool.queueUserWorkItem to call onNext. That's what return is doing here. It's actually calling to the scheduler to actually raise the message, which means all of this code, which is the user code in the onNext, is running on the thread pool. On the thread pool, you can't change the UI, you get this exception. So that's the first place where schedulers come in, is to parameterize things. What could I do here? I could say observable return 42 on the Windows form scheduler. What happens then? We are generating the onNext call on the Windows forms message loop, which means this code would run on the message loop, which means this thing would not fail. So you can parameterize where things are happening to make sure they're happening in the right spot. Now assume that my slide would contain 3 dots. var access equals ... I don't know where it comes from. At that point, you can't control where things are being generated. Like, they're generating it wherever they feel happy to. Right? Maybe there's a web service call involved. It will be the thread pool. At that point, we give you this observe on thing that you saw before, and you saw observe on dispatcher, which was an alias for access.observe on dispatcher scheduler, or control scheduler, or whatever UI framework is you're using. That basically means when messages come in to the original source, when I receive them, post them back to that scheduler to do the rest of the computation over there. So observe on control scheduler form means those messages happen on the thread pool. They still happen on the thread pool, but when I receive them, I will call my downstream observers on the Windows Forms thread. So I'm basically using the scheduler to jump to a different place, much like synchronization context of post, and in fact, we have a synchronization context scheduler, which takes a synchronization context and wraps it such that Rx can do a post operation to a different place. And so now this code would actually work, because maybe I don't control where it's happening. Like you get a sequence from God knows where, like then you do observe on. In fact, we have overloads to observe on that don't even show you the schedulers. We've actually added some in RxV2. We have observe on for dependency object and dispatcher object that actually allow you to do something like access.observe on, give me some control in WinRT, Silverlight, Windows Phone, WPF, whatever. We will fish out the dispatcher for you, wrap it in a dispatcher scheduler, and post back to that. So we're actually observing the messages where that control expects things to be observed, because there you can actually touch the UI. So that's just a matter of overloads. That's the interface. You can actually listen to a lot of Channel 9 videos on how the interface came into existence and the long story of the sad interface. It's actually not a sad interface now, it's happy, but it used to be a little bit sad before. But so what's really going on here is you have schedule methods that can do things, the actions, which are delegates, at sort of immediately, meaning as soon as you can, at a certain relative time, from the time you call schedule, say do something in 5 seconds, and it says, yeah, I will take care of it in 5 seconds, I will try to execute this code, or at a certain datetime offset. We did a huge refactor in our RxV2 to actually make things based on datetime offset actually happen at the right time. So if you say, I want to send birthday wishes to Bart the 11th of February, then you would actually put something in here, which is a long time from now, and we will make sure, modulo Windows updates, that that thing executes at that point in time. So that's what's going on here. Other things to notice here is the disposable coming out. That's kind of an interesting little thing. When I schedule something and I give it an action, what do I get back in return? My disposable. That action may run like a year from now or a couple of seconds from now. I have a disposable in my hands. It's happening asynchronously. When I call dispose on that thing, we'll try to prevent the work from happening. So we'll try to cancel it. So you get a cancellation mechanism back. You may have seen this thing before. Subscribe also returns an iDisposable. How do those things work together? The answer is, they just work together in a simple, stupid way. And that's why it's beautiful. Like, it's just a very simple layering in Rx. If you look at my previous diagram, concurrency layer at the bottom, event interfaces on top, link layer at the very top. Okay? The link layer is about doing things like subscribe to aware and returning an iDisposable that allows you to cancel things, right? Like subscribe gives you an iDisposable. In the concurrency layer, it's all about calling schedule method, schedule method, schedule method, schedule something at that time, schedule something at that time. You also get disposables back. How do those two things knot together? Well, let's actually take a look. This return thing we saw before, how does it work? I want to create a sequence that produces one and only one value. The value that's being passed to it. So I want to have just this little one value sequence. Because we don't know where we have to generate that on next message, we take in a scheduler. So that's what you have here. There's an overload that substitutes that for a default. So how do we implement this guy? It fits on one slide. First of all, look at the return type. What do you have to return? An iObservable of T. Now, don't act like a bull on a red flag or something. There's an interface. I have to implement it. Oh, no. We never implement the interface at all in Rx. We did that one time, 2.5 years ago. We're done with that. No longer implementing the interface. What we have is observable.create, which is a factory that takes in a subscribe action. And we'll wrap that subscribe action in an implementation of the observable. So we'll implement it that way. by just taking the implementation of the subscribe method. Why do we do that? Because we do some wrapping there. If the user calls dispose on the returned object, we want to silence the observer. Even things may still be going on, because like this deep cancellation may take a long time before the pipeline dies, but we want to return immediately from the dispose, giving the illusion that things are stopped. So you don't want to receive messages after coming back from the dispose. So we need to do some interlocked compare exchange on some internal observer to put a mute observer in place. And we need to do a lot of that dancing around there to make sure there are no race conditions. So we do that once and for all. That's all hidden in observable.create. Observable.create looks exactly like the subscribe method. It takes in an observer, it needs to return iDisposable. Observer iDisposable. So now I need to implement it. Functional programming is really simple. You just look at the ingredients on the kitchen table. I have some celery, some pepper, some salt, and I have a cookbook. Like, how do I combine those things? Maybe the celery needs to go in the jar, and then I need to put some salt on top of it. Like, yeah, something like that. So there's only one way to take those ingredients together to actually get to the result. To return observable, never think again. Observable.create. So this was simple. Like, everyone can do that. It's just in the recipe in the cookbook. Step 0. Return observable, call observable create. Beautiful. The soup is boiling. Next, what do I need to do? I need to talk to the observer, giving it the value. That's what I ultimately need to do. So what could I do in here? I could say something like observer.onNext of value. That's nice, but like, I was creating a beautiful dish here with lobster and caviar. That's the lobster and that's the caviar. And I'm not using the caviar at all. It's still sitting on the table. I'm not using the scheduler. Maybe I should use it in my recipe as well. So how do I use the scheduler? Let's take a look at this whole thing. I have an observer. I need to return an iDisposable. Where do I get an iDisposable from? Oh, I saw scheduler.schedule returns an iDisposable. We saw that on the previous slide. So let me actually use the scheduler recipe here, or the scheduler ingredient. Do scheduler.schedule, I'll get back an iDisposable. That's nice. Okay, scheduler.schedule returns an iDisposable. This thing is happy. Now I need to come up with something to do on the scheduler. What can I do on the scheduler? Well, I haven't called the onNext on observer yet, where I can feed in that value. So that's logical. That's the kind of thing I will do here. X.observer onNext x.value, x.observer on completed. That's the thing I'm doing here. There's just some wrapping of state into explicit anonymous thingies over here. But so essentially what's happening is observer onNext of value on the scheduler. So what's happening now? The user subscribes to this guy. When he subscribes, this code executes. When he subscribes, we schedule something. That scheduling will eventually, in the future, when the scheduler has some point in time, it can do that because there might be a queue or something, call onNext and onCompleted on the observer. And we return an iDisposable from the scheduler. That's now returned from the subscribe. So when the user calls dispose on that thing, he's really talking to the scheduler to say, don't bother trying to call the onNext anymore. It's a very shallow layering. The iDisposable of the scheduler just comes out. If you do something like sample, what's sample do? Sample says, I have a sequence, I have a scheduler, I have a timestamp. I will subscribe to the sequence. I get an iDisposable back. I will call to the scheduler to run a timer that fires every period, because I need to sample. I get an iDisposable back. I have two iDisposables, I bundle them together in a composite disposable. That's what goes out. And then that other thing, the guy who subscribed to the sequence is writing to a field. The timer is actually reading from the field, and also some Boolean state and some logs and some compares and blah blah blah, like all of that stuff. But so, schedule call, subscribe call, two disposables, hand them out. Like that's as simple as it gets. Like it's composition on the disposables as well. So the layering is really very simple. Now why would you care about that? Because the layering is simple and honest, everything in Rx has to go through the scheduler layer. Nothing can happen in Rx without talking to the scheduler. No messages can be born without talking to the scheduler. Some exceptions. If you're talking to a .NET event, it's coming from somewhere else that we don't know. But like if you're basically giving birth to a lot of those sequences inside Rx, it all has to come through a scheduler. So the scheduler is the oracle of truth. It knows everything. Everything that has to happen at which time. Christmas next year, send the birthday Christmas card. New Year sent this present to somebody else, call this action over there, blah, blah, blah. It has a global order of all the things that have to happen. So that means if we swap out the scheduler with something else, we can virtualize time. That's beautiful because we can do testing. What does that mean? If you say in Rx, I want to schedule something at Christmas, New Year, and 11th of February next year, like a long time from now. You're scheduling those things and you're running your application. Who says we have to wait that long to mimic that the things are going to happen? I know the order they have to happen in. And maybe when I receive, some Christmas gift, in that action, I might be scheduling new work to send the gift to somebody else as well. So like there might be work born when we're executing work, right? There might be dependent work sort of being queued. But the thing is, it's all sitting in an ordered queue. The first thing that has to happen from now is doing something at Christmas. So let's actually execute that. So how can we virtualize time? Just drain that queue as quickly as you can. Take the first thing, pretend it's already Christmas by setting the datetime offset of now, kind of equivalent in Rx to Christmas, so everyone believes it's Christmas. Call the action, they say, oh, beautiful, like jingle bells, blah, 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 and they schedule some new work, which enters the queue. Might be in the queue for June next year or something, but there was still work at New Year, so let's actually move the clock to New Year's, execute and pretend it's New Year, and so on. So you can actually condense all of that stuff. Very beautiful for log analysis, for example. You have 1 terabyte of log files for a data center of 30 days. I want to see what went wrong the 15th day. You're not going to run that whole thing for 15 days. You're not going to try to find simulations of the Higgs boson by running something till the birth of the universe or something. Like, you're not doing that. You're compressing that time and sort of trying to evaluate it as quickly as possible, not like waiting for 2 things to collapse or something. Like, just emulate that whole thing. So virtualized time allows to do that. Here's one use of actually virtualizing time using the schedulers is test scheduler. Where you can say, I want to test my query. I have a query sitting here, for example, using my phone. I have a beautiful application that detects when somebody, one of my friends on Facebook, for example, enters the city of Dublin 5 kilometers around the town square or something. Like, that's my application. Well, you could test your application by calling all your friends using like a Facebook event or something, like, please come to Dublin to test my application. You start on that state and you walk that way, and I should get the event. Like, and then there's a bug, and then you say, let's do this again next week, I will fix the bug. Like, you really look like a nitwit if you do that kind of stuff. So what you need to do is you actually say, I'm going to pretend that this is happening. I'm just going to virtualize moves of people in time. I'm going to say something like, Bart at this time is at that GPS long lat coordinate. At that time he's there, at that time he's there, at that time he's there. You just built an array of all the times that sort of correspond to the paths. Maybe you generated it by drawing on a Bing Maps or something. So you just generate a virtual sequence, and then you start playing that. And then you expect, around noon he's actually at that spot, the event should fire. My query should say there's somebody in Dublin that I know. I should get a notification. So you're basically virtualizing that time. So that's in fact like how we do often demos for like people like the Windows Phone team. How do you test your sensors? Not by going in the streets of Seattle and walking around the whole day. So what you have here is a virtual sequence that produces Bart and Eric at times 3 and 400. At times 500 it says the sequence is complete. Don't try to think what 300, 400 and 500 means. They're just ordered in time. They're actually ticks, but the ticks don't even correspond to CPU ticks. It's just some representation of time. So that's what's happening here. Now I have my mysterious query. I want to see whether this query is doing the right thing. From name and input, select name.length. At time 300, Bart enters the pub. And he has a length of 12 characters. Time 400, Eric walks in. He has a length in characters of 11. Then completed happens at 500. What does the outcome need to be? At time 300, I need to see 12. 400, I need to see 11. 500, I need to see completed. So I'm just going to assert that. I'm going to say results.messages.assert of this, that, and that at the same virtual times. Because select is agnostic of time. Something happens at a time, it executes the selector function, and that's happening at the same time, producing the next value. In reality, there will be some ticks, of course, in the real clock going on here, but here we go basically based on, point events. Like things are happening at a single point in time, we execute a lot of work, but time is not getting skewed by doing the select. If I would do a delay, things would get skewed, right? So let's actually just show you this testing capability. And in fact, let's also start this guy while I'm at it. But so let's just create a new test project in Visual Studio, a unit test project over here. Let's save all of that. And so let's actually show you how you write a unit test in Rx. You just include, system.reactive again, and Microsoft.reactive.testing, the right version, because I have 1.0 and 2.0 sitting here. This is our extension to the Microsoft.visualstudio.qualitytools or something, DLL, which is where the unit testing lives. So I'm just including those guys, and now I can derive my unit test class from reactive test, which gives me a couple of helpers. A couple of useful helper types over here, like some ways to mimic sequences, like to mimic an on next, an on error, and on completed, like no mysterious things here. But now I can write a little test. And I think I still have in my toolbox somewhere a little test case just to show you. Maybe I don't. Oh yeah, here it is. So I'm going to new up a test scheduler. That's very simple. And now on the scheduler, I'm going to tell it, please raise messages at those virtual times. At time 100 to this, at time 200 to that, so on and so on. So I'm going to create a stream over here, a stream of messages. At 2:10, it produces 42. At 2:20, it produces 43. At 2:30, it produces 44. And then at 2:40, it completes. So that's a virtual time. You can actually draw it with dots on a line, right? Like as we've seen before. Now I want to write a query on top of that, and I want to see whether the behavior is what I expect it to be. So here's my query. So it's a little, academic kind of query. From x and x's, where x is even, select x plus 1, and delay the results with 50 ticks. Which means only the even values survive, they get incremented with 1, and the whole thing shifts 50 ticks in time. So I want to see 42 and 44 because those are the even ones. They need to be projected onto 43 and 45 because I'm doing plus 1 over here. And they need to come out at 260 and 280 as opposed to 210 and 230 because I'm delaying the whole thing with 50 ticks. So that's what I want to do here. And this thing is not happy because I don't have system reactive link, which is where our extension methods live. And so now I need to assert this guy. How do I assert the guy? I basically write this assert that says at time 260 I expect this, at time 280 I expect that, and on complete I expect to happen at that time. That's your unit test. So when I execute this guy, over here, all tests, we should see all green somewhere. Where's that? I think this thing doesn't come out. Okay, there it is. So that's the unit test thing, and here you see the test method actually completed, the test actually passed, my asserts were right. Now, of course, if I thought like this thing should come out at 270, and this thing should come out at 280, but it should be really 47, like that's what I really thought that should happen, like I should get a notification that somebody enters the city of Dublin because he's at that point, but my mathematics is off maybe. Like this is really what I expected to happen. When you execute this piece of code, as you can see clearly here, this is not right, and what you get in the test method output is, we expected 43 at 270, 47 at 280, completed at 290, but actually, at time 260 on the scheduler's clock, we saw 43, at 280 we saw 45, and there's 290 for uncompleted. So that's what we saw. You go and figure out what's wrong. It's never our fault, so, that's the idea. In fact, we test all of our X using this as well. Well, not all of it, not the real concurrency aspects, but all the functional correctness is actually done in Rx using the test framework we have here. And so this is actually running the Rx tests. This will take a while because there are actually 2,800 or something unit tests here. So here it goes, 2,877. It's actually doing all of those things in virtual time to make sure that operators are doing the right thing. And so here you see, for example, here's a unit test. A real unit test for group join, which is one of our operators. It's the 5th test for error cases. And here is like some sequence. At 210 something happens, at 219 something happens, blah, blah, blah. And then over here there's another sequence that produces hat and bat and leg and pig and so forth. We just have some fun using names when we write those kind of things. And then here we're basically starting the scheduler to do a group join. Unfortunately, an exception has been thrown from one of the selector functions, and we expect the exception to come out at the right point in time. In fact, at time 210, apparently the exception needs to come out because that's the time we execute that piece of code from the end user. And so that's like an example that has a lot of stuff that actually not really executes here because there's an exception case. But like, of course, we also do the things for the ones that are not erroneous, like for this one, for example. The group join needs to produce this, but at 721 there is still an exception for one reason or another. And that's, I don't know where that comes from in this particular case, but there will be an exception sitting somewhere in here that we're raising, and we're asserting that the exception comes out at virtual time 721. Like, and it has the same identity, its object reference equals, like nothing happened to the exception object. We're testing all of that stuff as well here. So, and in the meantime, all the tests should have passed. Here you see, like, Rx has actually passed all the unit tests, and just running those unit tests in the case of Rx gives us a code coverage of, I don't know, not covered 0.39%. So that's 99.61% is covered just by doing the non-concurrent unit tests that actually do everything in virtual time. We also have concurrency tests in a separate project that really check for race conditions and those kind of things, of course. Because in virtual time, everything is really mimicked on a single thread of execution. It's purely to see that the output and the input relationships are the same. So, a few more closing notes. I talked about the difference between observables and events being a lot of things like higher order or like first-class representations, those kind of things. But there is one thing more that I haven't mentioned yet, which is the expression tree representation of queries. When you write queries using regular .NET events, you end up with if statements and sampling timers, and you don't see the forest for the trees. It's just IL code that the CLR is really good at executing, jitting and all of that stuff, but like, you can't put your finger on that. You can't really say like, what was the user trying to do here? Oh, he was trying to write a where filter. Let me take that where filter and run it somewhere else, closer to the data. You don't want to do something like, from tweet and Twitter, where tweet mentions Lady Gaga, select tweet, and then come to the conclusion you're also streaming everything about, like, the Olympics or something, just to throw everything out on your machine because it doesn't contain Lady Gaga. You've just actually created an entire copy of Twitter. You want to take the predicate and run it somewhere else. You want to give Twitter, hey, Twitter, please tell me whenever there's something being said about Lady Gaga, because I like that. And then, they can do the filtering close to their fire hose of data. So, we already have this in Link. In the past, we had like iQueryable of T for things like link to SQL, link to SharePoint, link to LDAP, link to Amazon, where you can do things like, just write a query, and it translates into things like T-SQL or Camel or whatever, the languages that the backend supports. So, we can do exactly the same for event processing queries. No surprise there. And this allows us to do things like link to Twitter, link to NASDAQ, link to PowerShell, link to WMI events. I will actually show the first one here in just a second. So this is the interface. Let's not talk too much about the interface. It looks exactly the same as iQueryable. Like, it has an expression tree inside of it, which you can inspect at runtime to find out about the user intent and to do a translation. There's no typo in the slide in case I see people looking weird. It's called iObservable. It's iObservable with a little tick on it. And yes, we're serious about that, like that's how we ship it. The reason is, there is a deep property that actually comes from the Lisp days in 1958, McCarthy invents Lisp, blah, 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 blah. What's really going on there is, when you write something, you can either do a quotation or you can write just the data, right? You either have the data structure or you have a representation of what the user wants to do. The way that's actually called in that world is called homoiconicity. Homo means the same, icon means representation, icity means the English people bastardized the Greek. So what's really going on there is like, it's the same representation. You have the same syntax, but it translates in fundamentally different ways. The user just sees a Lisp kind of thing. In that case, they have a little quotation syntax on top of that, but the rest is all the same. In this case, the same thing happens. You write your link query, you don't see it's going to execute somewhere else. You write from x in x's where x%2 equals 0, select x plus 1. Might run in SQL, might run locally, might run here, might run there. My syntax didn't change. That's the whole idea of link. You want to write the same query in C#, but it translates without you studying T-SQL and Camel and weird type systems. Exactly the same thing. So why don't we make the types look the same as well? IObservable, ICObservable. If you look at them, they look exactly the same. The beauty is, you only have one guy who needs to implement iQueryable or iCobservable. Millions of people can use it. So the one guy who actually implements that will have a little bit of fun and say like, this is a beautiful name because I understand its homoiconicity. So, we had a little bit of fun when we actually found out about that one. In fact, I admit now publicly that iQueryable should really be called iFnumerable, which is iEnumerable missing a leg. Like, it looks exactly the same. The queries look exactly the same. There's one guy implementing link to SQL and million people using it. Like, you never have to see that type yourself. So we made it homoicon, otherwise we had something like iQueryable observable, iObservable queryable, iQuery representation of observable sequence query. Like, that doesn't flow nicely. This is better. Okay, said enough about that. That's just a name, get over it. This is the picture. That's the important picture. The important picture is that we now have 4 quadrants in the way we approach data sources in the framework. Sources can be pool-based, meaning enumerators. Get the enumerator, move next, move next, move next, move next, like data readers, databases, SQLs, thingies, data readers, those kind of things. We have push-based systems. Those are observables. On next, on next, on next. You react to it. I'm telling you, on next, here's more money. Like, things that you can actually analyze and make money out of. Like, you're not sitting there and pulling things out of NASDAQ. Like, you're basically doing other useful stuff and they're telling you things are happening. So, in the pool-based world, we have iEnumerable of T with link to objects. How does it execute? It executes locally in process using IL code. How's the IL code written? Using iterators and C#. Link to objects is just written using iterators and C#. For example, the where is just for each x in the source, if predicate of x is true, yield return x. Yield return, yield return, yield break, yield return, that kind of stuff. That's just generating IL code, state machines, the CLR executes that whole thing. You can't look at it and understand what it's doing. Even Reflector has a lot of problems with iterators, as far as I can tell. Secondly, observable of T. How do you build those link to events operators, like where? I told you before. When you have to return an iObservable, use observable create. When you have to return an iEnumerable, C# says use yield return. Like, it's the same kind of thing. So that's observable. Also executes locally. The pipeline runs on your local machine. However, we always had link to SQL with expression trees for iQueryable. iQueryable takes an enumerable style query, runs it somewhere else by means of expression tree translation. So we add to that iObservable, which is iObservable, style queries, push-based queries, but represented using expression trees. And so now you can pick up the user intent and run it somewhere else. So an example of that is link to WMI, which I have sitting here, not here, I have it sitting here. I'm moving over to VS 2012, so it's actually moving to the left on my taskbar. So here we go. Here's a little query. What I'm doing is, and let's actually simplify the query a little bit without those kind of things first. Ignore the things in green at this point. What I want to do is I want to observe, using a queryable observable, process start traces. This you can find on MSDN. It's something in WMI, which is infrastructure in Windows, that can tell you about process IDs and process names whenever the process is started. That's nice, that's convenient. So now, what I want to do is I want to write a query on top of that to get the process name and the process ID for every process that started on the system. Okay? So let's just execute this thing. There we go, it prints a magic string, which we'll see in just a second. And sometimes Windows feels good and starts some, search filter host or whatever kind of thing. In this particular case, it feels actually even better and thinks there's no work to do. So let's give it some work by starting the calculator, starting control, task manager, starting notepad. And so what you're seeing is you get process start traces for all of those guys. WMI is telling my application a process was born. Do something with that. You can react to that. So that's nice. But now say that you have this running on 100 machines or 1,000 machines in a cloud data center, and you're just looking for the presence of malware. You're looking for Trojan.exe or Slammer.exe or something executing on any of those machines to raise a red flag. Do you really want to do this? Select all the process names and process IDs from all the 5,000 machines, aggregate them on that single machine that's watching out for malware. Like, your network traffic is monopolized by doing just purely analysis. You don't want that to happen. So you want to actually take the query and run it in WMI, because they can filter things remotely. They can filter it as closely to where the data is born. So let me actually write something like where process name equals notepad.exe. So now, as you can see, that link query in C# syntax, 2 expression trees, translated at runtime into a WQL query that WMI knows how to execute somewhere else. They know how to analyze process name equals notepad.exe, and likely to do simply string compare somewhere on a C data structure close and deeply in the kernel. Like, that's beautiful. That's exactly what I want. I want to push that down as far as I can to all the machines, to all the internals, as opposed to have it leak out over the network into the CLR, where it has to take out everything except for that one red flag a moment. You don't want that to happen. So now, as you can see, I can start Notepad, I can start a couple of calcs, I can start more notepads over here, and as you can see here, there are just 2 notepads being triggered for 3 notepads because I started 3 of them. And the calcs don't survive my filter, which is now happening in WMI. So that's nice. In fact, like, this machine has a little soft key for calc, and this machine is smaller than that machine. So when I was actually preparing demos at some point, I was doing my PowerPoint here, I put that thing on top of that other machine because this thing is so much smaller than that guy. I was sitting on the soft key of calc. This was really looking nice, in this thing, like, calc, and I looked back and I saw, like, this was just a cascade of calcs sitting here, like this kind of thing. Windows is pretty good at actually doing that kind of stuff, but not if you're sitting there for 30 minutes pressing a calc button. Weird things are happening. But WMI is just happy analyzing that. In fact, what you could do is, of course, something like over here. You could actually say, I have done enough in WMI here. I know you can do filtering, but I know you WMI, you don't do anything with time that's interesting to me. But I can use Rx. I could say, let's do as much as I can in WMI, and then do the rest of the execution locally. Let's do the rest of the execution in the process, with time-based analytics and all of that kind of stuff. So what if I actually do something like count, or actually get calc processes, and then convert the queryable sequence, the queryable observable sequence, into an observable, a local observable. What's going to happen now is that the rest of the code executes locally. It's exactly the same as in link to SQL. In link to SQL, you say as enumerable. Everything above the as enumerable is translated to tsql. Everything below the as enumerable happens locally in the process. So I can do the same thing here. And so here I'm just going to analyze from seconds 5, select b.b.count. So for 5 seconds, I'm going to basically select statistics of the number of calcs that were started in 5-second windows. Now, of course, I could say something like where b goes to, or n goes to, n is larger than 10, select alarm or something. So like there were more than 10 processes created in a 5-second window, there is an alarm. There is something happening on the system I didn't anticipate. So now you can do those time-based analyses as well. So let me actually run this thing, and I'll just press a couple of calcs here. That's not more than 10 in that window. And in fact, I should have dumped. In fact, let me show how to dump some stuff. What you can do in Rx is also this. This is a pipeline. All those dots are an electric wire that basically has on next messages flowing on it, right? Like now you're the electrical engineer and you're looking at that whole circuit and you say, oh my god, I don't understand how this is ever going to produce an alarm. Like it never really happens, and I need to debug this kind of thing. like what you do as an electrical guy, you say, you know, I have a circuit here, like that's beautiful. I want to see where this thing is doing something. You basically cut it open and you put an amp meter in between. And then you look at that little thing and you see like, oh yes, there's current flowing over here. Let me see whether there's still current over here. Oh, there's no current over here. Something went wrong in this piece. So you actually want to intercept the flow and basically put some probes on it. We have a probe called do. So you could say over here, do n goes to, and then write a little piece of code here where you say console.write line, maybe, of, that's a probe that will print n. So that's printf debugging. What's happening here is, the input thing you're selecting, every 5 seconds the probe will actually see a message, it will execute this piece of code, and just pass the electron through to the next phase. So it's actually intercepting it, just making that thing wiggle a little bit so that you can see what's going on, but the query is not distorted in any way. It's just like a little piece of code that's executing solely for its side effects over here, in this case printing to the console. So as I actually execute this thing, what's going to happen is every 5 seconds I will see my debugging statistics here. Like there were 0 calcs in that window. I will start some calcs over here. So those are the calcs that will be picked up by the next window somewhere. WMI has a little bit of lag, that's by design. So what you're seeing here is like 4 calcs were started in that 5-second window, like where they actually came into the system. So everything is still steady state, there's no alarm yet. Of course, when I'm sitting there with my calc on my lap somewhere, like then that's the kind of thing that's happening. That soft key has really good repeating functionality, it seems. But so there you see there was an alarm of 98 in 5 seconds. So that's the kind of thing you're now seeing happening here. There's still an alarm. There were 17 events still delivered in the next phase, and now the system is going calm again. 0 events. That's beautiful. So it actually shows how you combine remote execution with local execution, because you don't want to suck in all the data from the data center there for all the processes. You just want this. You also have like process or thread start trace, for example, which of course is much more noisy. So that shows this kind of thing. And so now I really have some wrap-up things. Stream Insight, how many of you know Stream Insight? Okay, so it's an event processing system built actually in the SQL organization. We work very closely together. In fact, one of the things we've done in Stream Insight 2.1 is you can pick up RX queries written using IPObservable and run them in the Stream Insight server. So that's based on taking the expression tree, running it somewhere else. Something we've been noodling around with for a long time, that's now supported. So you can actually pick up RX queries and run them elsewhere using this mechanism. So the future of RX, I've actually talked about it in many places, from event pattern, knowing about WinRT, support for the .NET Framework 4.5, task of T support, all of that stuff. So let's just go briefly to some of those things. We support the async programming features. You've seen it before. Task of T, first-class citizen in RX. Before we had something called from async pattern that dealt with begin and end invoke pairs, because that's sort of going away in the DCL. We're actually deprecating those guys in favor of the task-based guys. Makes a lot of sense, like they're just going wherever the framework is going there. However, task of T by itself is a very beautiful abstraction, but you can hit a certain roadblock at some point and then sort of start grabbing 2Rx to make it light up, to do more powerful stuff here. That's what I'm going to show you on the next slide. So that's one of the ways we support task of T. As we say, a task of T is really like an observable. We can convert between the two. Next, we support await support. Well, we support await, which is this new expression type in C# on top of observable sequences. What does that mean? Await, how many of you know what await is? Like, see it? Okay, so that's a new feature in C# 5.0 that allows you to do imperative style coding in the face of asynchron. So you can say something like await a web service call to happen and to complete, and then when that await is done, the result gets assigned to some variable and you write the rest of your code. I will show an example in the next slide. And so what we do is we add support for await to observable sequences as well. What this allows you to do is, for example, you sit in some button click event handler and there you say await nasdaq.take24hours.average value. What that means is that the program is not stuck for 24 hours waiting for the Nasdaq to close like at the end of the day. It's actually just saying, okay, I've recorded this, I'm listening to NASDAQ, and when that's done, the rest of your code in this method will actually execute whenever NASDAQ is done. So you're basically sequencing your code using await, but using the observable sequences. I will show an example in the next slide. As part of like all this stuff with like things that can be blocking, that are sort of forbidden in WinRT and all other places, we're deprecating some blocking operators. We also have better exception stack traces, you know, that's all like debuggability. So I have one more slide here on the async programming landscape, and actually shows you this whole await picture. Again, I like slides with 4 quadrants because like they're really beautiful. If one thing is missing, you can basically walk to your boss and say, please fund our project for the next 5 years, and we'll actually fill in this gap. Like, you know, people buy this when it looks like this. When you just have bullet lists, they say like, I see 3 bullets. Like, why would we add a 4th? Like if you do this, like, oh, and you have a big question there with somebody taking out his hair, and it looks like, yeah, we have some flaw lists. So, what do we have here is we have synchronous single value code. We've had that all the way since the beginning of imperative style languages and any higher order language that you can think of. So that's function calls. You call a method, you give it some inputs, you get something back. Like you call console readline, at some point in the future, it might take a long time because the user might be taking a nap, you get a string back. That's what this is. A type to represent this is func of t. Func of t is something that returns a t at some point in time. How do you program it? Depending on what you like. You use things like semicolons, curly braces, like you sequence things just using statements in C# or VB. That's the way you program this thing. That's what you've been told for a long, long time. In C# 3.0 we told you how to program multiple value synchronous streams. So you say, oh, I have an enumerable sequence. In fact, in C# 1.0 we said like enumerable sequences, you don't want to have something like get the iterator and then do like a begin and end and compare that thing and then do blah blah blah. We said we give you a for each keyword. That's nice. For each keyword, nice syntactic sugar to actually make that move next pattern much nicer. But in C# 3.0 we said like, you know what, if you're doing a for each with an if inside and then you're stuffing things into a dictionary based on a key and doing a count and all of that stuff, why aren't you writing a where with a group by and an aggregate operation? Like that's the kind of stuff you've been doing in SQL all along. So multi-value programming for synchronous sequences use link to objects. Now we also have asynchronous language support for single values. What if you're doing a web service call? I'm doing a web service call or a web client call and I say I want to download some string from the internet. What does that thing return? If it returns a string, you host, because you're waiting for that thing to come back. Your thread is hanging like nothing's happening till the web server replies, and maybe you get an exception. So you need to go asynchronously to do that stuff. So how do we make that asynchronously? Well, in the past we said, you have begin invoke, end invoke, maybe you have a begin operation with a completed event, like all sorts of things that put your code into little pieces on the floor and you don't see the forest for the trees. So what C# 5.0 did is they said, we're going to add this await keyword, VB11 does the same thing, that basically says, I'm starting this asynchronous operation F, which takes in X, and eventually it's going to give me back something that I want to assign to Y. Eventually, might take 10 hours or something, like ultimately there will be something coming back. In the past what you had to do was like, everything after that async block needed to go into a callback method. Like the method that you register with that thing, maybe an event or whatever, like if F completes, I want to execute the rest of my code. That's sitting somewhere else now, maybe on a lambda expression. Like it's really taking your code into little pieces. So with await, the compiler does that. The compiler says, I'm going to start this operation, and when the operation completes, I'm actually going to execute the rest of the code here. So we have await support. How do you program that stuff? Still semicolons, still if statements, still while loops, still using blocks, still try catch finally. All the things you learned like a long time ago work for asynchronous programming now. That's just nice. Like you can do all sorts of control flow using that thing. How do you do multi-value asynchronous programming? We already know how to do multi-value programming. You say you use link. The only difference is we don't have a for each keyword, because that would be blocking. For eaching over an observable sequence would mean wait for the next element. No, you want to have a callback. How do you register a callback? We have subscribe and lambda expressions. That really looks pretty simple. So the same syntax over here, the same syntax over there. So that's really what's going on here. .NET 4.5 adds this, our XV2.0, and actually our XV1.0 add this as well. And so it makes sense that those things can be converted from one thing to another. So here's an example of using the new async stub in C#. Get HTML async. I have a URL, I have a web client, and now I actually want to get something from the web, right? I want to basically do download string task async of a URL. What I will get back now is a task of string that will actually tell me when the value is available. It will be in the task object over here. So how do you fish it out? Well, in the past, you would actually write things like this. You would have web client equals new web client, right? And then you would say web client dot download string, or let's do something like begin download string of the URL HTTP something, right? And then you would have to say when that thing is done, I get an async result, and when the async result is back, I can do end download string of the async result, and then I have my HTML. And then the rest of the code would be sitting here. That's how you had to structure your code before. You basically had to put things inside out. Like, everything after completing the download needs to run in the continuation. Now try to put a while loop around that thing. That doesn't work. Try to put like a try-catch around that thing. That doesn't work. Why? If you put a try-catch around this thing, you're only like this. This is not C syntax, by the way. Like if you're doing this, this catch only refers, or actually only covers this guy, because this is a new method being generated. So you would have to put a try-catch around this thing as well. So you have a lot of problems to actually do this control flow. So instead what we say, in order to make this much easier, we want to write this code linearly. So we say var HTML equals await web client download string async of the URL HTTP this, and like that. And so now what the compiler will do is it will actually, and this code goes here, it will actually do a rewrite that looks a little bit like this on your behalf. It will say everything after the await, so the operand to await executes at the point of like executing this code path, and then it says, oh, the web client is not done downloading yet. Let me take all the rest of your method, lift it up, and actually give it to the task to run at the point the task is done. And then that method starts executing the rest of the code. It also captures, at the await point, actually also captures the synchronization context. So when it resumes the method, it goes back to the original context, so you can still touch the UI. So there's all sorts of things there. The exceptions, whether they happen at the beginning of the operation, the end of the operation, they come out through regular control flows. So you can write a single try catch. You can put a while loop around it, the using statement, like all of that stuff works. The compiler splits your methods into pieces that execute as a little state machine. This thing is done, let me run the next part. Oh, I'm blocked again. Well, not really blocked. I'm waiting for something to happen. Let me tell that thing to call me back when it's done. If you're done downloading, call me back, and I will kick the method in the back to continue executing a little bit more till it's waiting for something else to happen. So it's awaiting the completion of something. So that's what's going on here. So when you actually use this, you can do fancy things like timing out an asynchronous operation. That's what I'm doing here. You can do something like task.delay, which gives me a task that says it's done after the specified time. So after 30 seconds, this task will say, I'm done. So basically, what would happen if you would do something like await task.delay, it would mean your method runs to the point of the delay, and then it will release control to do other stuff during that 30 seconds. And after the 30 seconds, the rest of the method will execute, will be scheduled to execute. So what you can do now is you can do things like timeouts by saying, I want to wait for either the download string to complete or the delay to complete using this when anything that we have in .NET 4.5. and then you check which one has actually come through. Now you will look at this, that's a lot of semicolons, and you will likely say Bart doesn't like semicolons, he likes fluent style. Like he likes, just chaining things together. In fact, I don't really like this unless I'm a kernel guy. Because this really, when any has exactly the same feeling and behavior as wait for multiple objects EX, or actually message wait for multiple objects EX, which was introduced in NT back in the late 80s by Dave Cutler, who said, well, you need a way to actually wait for multiple things to happen and then have a primitive that actually signals you back when any of those things complete. So this is still that kind of structure. It's great for imperative guys. Imperative guys will say, I will do wait handle dot wait any, pass in an array, and then check for the index to see which one came back, and then do some code based on that. But to do a delay or a timeout kind of thing feels a little bit artificial to me. Like I'm awaiting a web service call or a timeout timer, and then when the timeout timer fires, I want to cancel the web service thing. Yeah, it sort of feels reasonable, but maybe you can do better. And so what we're doing with the Better Together story with Rx is this. Hey, we have a web client. Same thing as we saw on the previous slide. We have a download string async. Okay, that returns a task, but the task is a lot like an observable, right? Yeah, you can actually convert a task to an observable sequence. We've seen that happen before implicitly. So, we can convert a task to an observable. Now when you dot onto that thing, what do you see? 100 methods or so that all come from Rx. You can delay it, you can sample it, you can throttle it, you can do this and that. A lot of those things don't make sense. Sampling a task has only one value in it. So like sampling it, throttling it, maybe not. Wearing it, maybe you want to filter what's coming back. But timing it out, that makes a lot of sense. Doing exception handling, like dot retry, we have a retry method, makes a lot of sense as well. So you can do toObservable dot timeout. And now what you have is an iObservable. Now you say, I have an iObservable. Am I not losing the await support now to do the rest of my code in a nice way? No. Because you can just write await download. What's download now? It was a task, it became an observable, it stayed an observable because it's timeout, it goes from observable to observable. Awaiting a download takes out that one value at the point of completion and executes the rest of the code. So how does this await support actually work? The answer is C# has a big tradition, and VB as well, of actually not tying language keywords to any particular implementations. There are a couple of exceptions, like the lock keyword is tied to like the monitor, enter and leave kind of things. But things like, for example, the for each keyword don't even care about IEnumerable of t. C# says for each means I need to find the getEnumerator method. I found one. The getEnumerator returned a bar. The bar class has a moveNext method on it that returns a bool. Check, that's good as well. It has a current property that returns a foo. Let me bind to that one. Has a dispose method. Not needed, but if it's there, I will actually use it as well. So they just recognize patterns. Link is all based on patterns. If you write a where keyword, it means look for a where method. I don't care, it's enumerable, observable, or something else. I will just look for one. If I find one, I will use it. Same with await. Await says, if I find something called getAwaiter, which by the way, there is a typical joke in language design teams all the time, that like we also should have getAwaitress, because otherwise people are complaining. But like, so there is a getAwaiter method. The getAwaiter method returns an awaiter type that has an is completed, uncompleted, like a lot of methods on it. As soon as C# finds those guys, it uses them. Like it doesn't care, it's a task of t, it's an observable, it's a winRT type. As long as it matches the pattern, it binds to it. So RxV20 has a getAwaiter extension method on iObservable. That the C# compiler happily and merrily says, I will bind to that thing. So you can have await support for this. Which means you don't have to do this task.when any kind of voodoo dance. You can just say, I have a task, make it an observable, now I can use Rx to do a timeout, I can await the whole thing. You can await things like, waiting or awaiting the closing price of NASDAQ, which may happen in 24 hours. It all happens asynchronously, your program is not blocked, you can just write an await. So for example, if you have NASDAQ here, like you can now write something like closing equals await of NASDAQ dot take of time spent from hours 24. We have a take overload now that takes in time, and then you want to say something like sum, or well, not sum, or average or something. I don't know what's the meaningful value. what this does is, iObservable of stock ticks, take 24 hours means take 24 hours of the observable of stock ticks and then base it completed. Average says I will just compute the average by computing the sum and the count and doing the division at the end. So after 24 hours, this thing actually returns the resulting price, and the rest of the code starts executing. At that point, you may want to do something like smtp client.send mail to Bart, Nasdaq close, blah, 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 blah. So you've just written that code, your program is not stuck. While the await is happening, it's returning to its caller, doing other stuff, like the UI is still pumping. But at the end of the day, this thing fires and the rest of the code starts executing, sending a mail to Bart saying, this was the closing price of Nasdaq. So, better together story, you can do, all of this RxE stuff combined with the async stuff. We support WinRT, we've seen that before, not much to tell here. We're investing a lot in portable library support. How many of you know portable library? Couple? Okay. So, portable library is this project where we are saying, well, it doesn't make a lot of sense for you to build the same components for your application that have to run in different places. Like today, you have Windows Phone, you need to compile for Windows Phone. You have desktop, .NET 4.5 on desktop, you need to compile for that. You have Silverlight, you need to compile for that. You have Metro, you need to compile for that. You have Azure SDK, you need to compile for that. Like, that doesn't make sense. The framework is everywhere, it's largely the same, there's a huge intersection between all of those guys. So you have portable library, which actually ships with Visual Studio 2012. We're saying, now you can build portable class libraries that, without recompiling, just run as is on all those platforms. So you build that thing once, for example, your business logic for your application, you compile it, you say in portable library, you want to run this thing on Silverlight, Windows Phone, Windows Metro, and .NET 4.5 and Azure or whatever, and it will actually build an assembly. Make sure you're not using anything that's not supported on any of those platforms, you're in the intersection, and then it says, here's your portable assembly, you can use it everywhere. Well, what if you use Rx? If you use Rx, you also want that kind of thing, right? Like you want to take a dependency on Rx for one of your libraries, but you don't want to have to recompile that whole thing for different versions with if-defs maybe. So we actually made Rx portable in RxV2. So we have a couple of assemblies here. Those three assemblies are in the same colors as my architectural slide. Core contains the schedulers, link contains the query engine, interfaces contains the core interfaces. In fact, the core interfaces for a part actually in the BCL, iObservable and iObserver are in the BCL, so those are just a couple of other ones. We layered it this way because this is the huge piece of code, like this is a big query library. In a lot of cases, you don't even need the query library, for example, to bind the UI, a sequence to the UI or something, or to do remoting. Like you don't need querying in order to do something like UI binding. So we said like, you split it up here so you don't have to take a huge dependency just to do something like, I got an observable sequence from someone, I need to render it on the UI. Yeah, just include like those 100 methods of link, which is like so many kilobytes or megabytes of assembly, which is relevant for things like Windows Phone marketplaces and those kinds of things. So we said like core is sitting over here, we built some stuff on top of that, and we built something next to it. So on top of core, we have support for all the UI libraries, WPS, Silverlight, Windows Phone, Windows Forms, the Windows runtime specific things, which is actually an assembly that likely will move into this guy, and remoting support. So we have all of those platform specific things outside the purple area, which is portable. And then next to that, because portability means you can only use things in the intersection, right? Like things that are on all platforms. Which means often you have to do things that are suboptimal because there's only one platform that supports the optimal thing and the other ones only support the suboptimal thing. So you have to fall back to the suboptimal kind of capability. That's not nice that you sort of are losing optimizations based on the fact you want to be portable. That doesn't make a lot of sense. So we said we put this assembly next to it and you don't have to care an awful lot about it because like if you use like Windows 8 and you do the extension SDK stuff, we take care of it for you to include it. If you use NuGet, you will get this assembly as well. You don't even have to see it. And what this guy does, platform services, is it's a little bit like virtual machine editions in virtual PC or something. You have a virtual PC, it's running that slow, right? Like, but then if you install this integration components, it installs some weird drivers and things into that guest operating system, and the thing flies because it knows it's being virtualized and it's doing all sorts of crazy stuff there. So those are like the guest editions. Those things are not portable. There is a version for Windows Phone, Silverlight, and blah, blah, blah. And it knows about the platform it's running on. You're running on Windows 8? I can talk to the WinRT. Let me do that. That will be much better in terms of performance, isn't that? Oh, you're running actually on the CLR. I can use the TPL. I can use the task pool. I can use this and that. So that's what the platform enlightenments actually do. They actually talk to the platform-specific capabilities, and those guys know how to talk to it. But so when you depend on those libraries alone, your application becomes portable for today .NET 4.5 and Windows 8. In the future also for Windows Phone 8, where we'll actually move to the same subset here. So that's the idea of portable library. Basically means that you don't have to have that many copies of your code or that many copies of your assemblies. In fact, like Reactive itself will get a lot smaller based on this. Because like today, if you install Reactive extensions, like v10, for example, or 2.0, you get a copy of all the DLLs for Silverlight 5, for Windows Phone 7, for .NET 4.5, for .NET 4.0, for .NET 3.5, for this, for that, for all of those platforms. Then you look at the number of assemblies we have here, you multiply that with the number of platforms. Like, that's a lot of assemblies. And then you have to pick the right one if you're building your app. That's also kind of obnoxious. So this actually puts us on a track to be better there. We did a lot of performance work. I didn't even talk about like a lot of that stuff in passing. But so, now, essentially we didn't really have people complaining a lot about performance. In fact, there were a couple of cases where we were using this for like server monitoring scenarios, and they don't even care that much about like how much things you can do a second. They more care about like how much GCs do you take, or how much CPU are you using? If you're using 80% of the CPU for just monitoring, you're out, right? Like, we don't want to spend our machine budget on just monitoring whether things are going smooth or not. Like, so we did a lot of stuff to actually make the thing work better with the GC. And while I was sort of at it, I said, yeah, let's actually look at some of that performance stuff as well, because there were some low-hanging fruit kind of things in a lot of places in RX. Because in RX v1 we said, this is really tricky business. Like, we found really subtle things and race conditions and all kind of stuff like while we were developing it. By RTM, all of those things were solved as far as we know, but like, it was really brittle to sort of start playing around with things. At the point you're still inventing the abstractions. Like the scheduler, for example, went through 3 or 4 iterations. Like, as you're still doing that and you don't know exactly how the interface is going to look because you're still like shaving something off here and sort of polishing stuff, like at that point it's not a good time to start doing a lot of performance work, because maybe the next day we say, the interface is different, throw out all of that stuff again. So we said like correctness first. It's always good to make something fast. You can always make something fast if it doesn't have to produce the right answer, right? Like, and that's not the kind of thing we wanted to do. So we said in RX v1, let's focus on correctness. Let's be very pessimistic about locking and all of those kind of things, and let's have single abstractions. But so in RX v2, we added a couple of specialized scheduler mechanisms. It's also better to deal with certain time skew issues and so on. And this is like a picture. I just took the ones that look better, of course, like just to show the picture. In reality, that's one of the beauties. Like, we did some fundamental changes and it made everything better. That's what you really like, right? Like, you don't like to go into a code base and say like, I'm going to optimize this thing, but now that thing sort of gets a little bit slower or much slower. And then it's like a discussion of like, yeah, but most people are using this, but what about the poor 20% that are using that? Like, now for them it got slower, and like that's not really what we wanted. So we actually went for fundamental changes across the board. And so, for example, producers like observable.range, observable.repeat, those kind of things got a lot faster. Like, repeat could do 4,000 messages a second. I was sort of like sitting there with a red face in my office, like, yeah, repeat can only do 4,000 messages. Then we walked out like after a weekend and we said, now it can do 67 million messages. Like, oh yeah, that's nice. Yeah, so we did tighten some bolts there. Like, other things weren't that dramatic, of course. Like, multiple wares adjacent to each other did like 23 million messages a second, now it does 27. like, yeah, that's not that, you know, much of a difference, but still, it's quite a bit in order to do large volumes of data processing. But so just, you know, keep those numbers sort of in mind. We're talking about millions of messages a second, you know, like that's what we can do in terms of the pipeline. So that's a lot of stuff. So preview RxV2, we've actually seen it in passing. I showed you the task of T support. I showed you the await support actually in the slides. So there's a lot of stuff there. We've seen, like, you know, add reference to the reactive extensions SDK, very simple checkbox in WinRT, very simple things. So in fact, you know, I thought there would never be an uncompleted message in this slide deck, but, you know, there is an uncompleted message, which is actually the summary slide. You know, big relief. You know, using Rx and Link, what you can do is, like, tame your event streams, and I really mean tame them. Like, it means not just, like, unify them to have a single abstraction, but it means, like, you use a lot of those common pieces of functionality that you write once and reuse multiple times because you have higher order streams, and you basically say, look at this, like, this is a pattern I see coming back all the time. Like, I want to do some throttling, maybe I want to do some aggregation, this and that. And so you start extracting those things and build common, like, little query operators yourself. And so you're really taming that by building a toolbox of little helpers and stuff. And often enough, you just find everything that's in Rx to be just enough. But you can always go further. That's the beauty about it. Like, you have observable.create. You have observables. You can subscribe to them. You have schedulers. You can schedule things. You can build your own query operators rather easily. Like, it takes a little bit of craftsmanship, and, you know, multiple observables can come in at the same time, so you need to have some locking and stuff. Like, there's some stuff to think about, but that's in general with asynchronous program. But the thing is, like, if you just walk up to observable and you dot into that, you just see a huge library of things you can do. And often enough, you find that to be exactly what you're looking for. Where can you get it? You can just go to the download center, then you get an SDK, which is an MSI installer. We pop up in the add reference dialog, so you can find us over there. This is really useful if you're using Windows 8, because then you get that extension SDK thing. If you're using NuGet, just use Rx main, and you get also all of the dependencies sucked in. Just make sure that you have include pre-releases checked, which is a new checkbox they have in their add reference dialog. Because, like, RxV2.0 is actually a pre-release, and by default they don't show it in the dialog. So today we have RxV2 RC available. We are still working on a couple of known issues and maybe some unknown issues as well that people will find, of course. But so it's an RC, so there are some things to watch out for. But RxV1.0 is available. You can use that. It's stable. It's really tested. It's what, for example, Stream Insight uses, System Center, PowerView. Like, a lot of technologies today that are shipping are actually using RxV1.0. So that's a really stable basis. For V2.0, we're still, like, you know, solving a couple of things there, but we're very close to being done. And we'll actually have a release as close as possible, which means a couple of weeks at most, after .NET 4.5 and Windows 8 RTM. So, you know, that's gonna happen when it happens. I don't know exact dates for that. So. Then we have, you know, some videos on channel 9. So lots of stuff there. I think there are like 50 videos or something. You can just, you know, basically, like, I made this joke. I don't know what it actually holds in Ireland as well. But, like, I went back to Belgium a couple of weeks ago, right? And I just, you know, sat there and, you know, I said, like, well, I have some presentations to do next week and I want to prepare them a little bit. Let me just sit in front of the television. The whole evening, what you see on whatever Flemish television station you go to is cooking programs. Like, people are cooking, people are cooking, people are cooking, people are cooking. I say, like, we should really have a Channel 9 channel here. Like, and you can look at all this wonderful RX stuff and look at all of those videos, like, instead of cooking programs everywhere. Like, I don't understand that. So if you have to sit in a couch, you know, next to your wives or your husbands or whatever, and you're sitting there and you're watching cooking programs, put your earphones on, just go to Channel 9, you know. Cooking, you know, don't do that kind of stuff. And then, you know, we also have forums on MSDN. They're very active, you know. There are great forum contributors there, like if you post an answer. Typically, I don't see the question before somebody else already answers it, so it's kind of nice to have that kind of involvement of the community as well. So that actually brings me to the end. There was related content at the conference, so that's not really what I need to show here. So I will stay around a little bit longer if you have questions. Maybe some people want to leave and go and look at cooking programs tonight. Then feel free to do so. If you have questions, maybe while the recording is still going, I might answer a couple of them. So are there any questions, or do you prefer to ask them in a bar or something?
I just kind of want to get at the observable. How do you control code that gets executed on the other machine? I think RxX has some sort of prototyping of things that they have security concerns. So how do you lock that down?
So the question was like, how do you block down code that you run remotely using things like observable, right? And the question is like how you really transport things. Like, so if you have a target language you're translating to, so if you're doing translation like to things like WQL or something, they've typically trimmed down their language, right? If that's not the case, then you're basically on your own to sort of make sure, like, maybe you do a visit over the expression tree to see, like, are you only using safe APIs for some list that you consider to be safe? So maybe you say all the methods on system.string are safe, those kind of things. But then, of course, you lose some power. So maybe it's also more about, like, a constrained environment where you say, like, the only things that can deploy code are the ones that actually, are trusted based on some total or terminal concern, like some security boundaries or whatever. But like in general, taking up an expression tree also means taking a lot of the dependencies with it. Like for example, if you have an expression tree on an IKE observable of stock quotes or something, you will have to have the assembly that defines the stock quote type on both sides, unless you do some mapping from types from one to the other, right? So it's typically a deployment concern if you do those kind of things as well, which means you have to deploy an assembly, which also means you have code access security and those kind of things in the picture. So you could piggyback on those because you need to deploy things as well. But it's not, there's no silver bullet for like deployment of code, so yeah. Other questions? We have diehards in the room. Yeah.
I have a question. Is there a way to persist your stream state and then recover it?
Okay, yeah. So is there a way to persist and recover the stream state is the question. So like checkpointing as we call it in, for example, in Stream Insight. So today there isn't, because there are a couple of nasty things we have to think about. In particular, streams can be higher order, and that brings a lot of concerns with it. So what that means is like a stream can carry streams. You can have streams of streams. When you have that, it means like you need to remember a lot of state. Like, this guy is observing an image stream, and there are disposables and all of that stuff. So what we recommend people to do typically, like if you want to do that checkpointing, is to put it externally. Like we don't want to put it huge in the core foundation of Rx. Like there's a lot of stuff going on there, and we would have to put it in every single query operator. And maybe there is a reason to do that at some point. But so what we say is like you use things at the edges that you can replay. So we have things like subjects, replay subjects. You can even use schedulers there, like historical schedulers, to basically have a queue of work. And we have base classes where you can actually just define your own queue. And so there you could do some persistence and some other things as well, that like so much we have executed in the scheduler. So it's a little bit of manual work on that edge. Then if you want to checkpoint things in the middle, I would basically say, you have your pipeline, you could chunk things up. You could actually say, I'm going to use do, for example, to say like I reached this point in time, and so I'm going to write something to a log record, or maybe use CLFS or any of those logging systems to actually say I got that far. But like the pipeline itself is agnostic of all of that stuff. Now, one of the things that I have to point out that we've done is when we had the scheduler abstraction, we said like, wouldn't it be nice to take schedulers and also be able to use the scheduler as a place to control where things happen. So like if you say, I have a scheduler and it's the cloud scheduler, and I do something like observable.range or observable.time at 0 to 100 on the cloud scheduler, couldn't we run that somewhere in the cloud? Could that thing not be the scheduler and then call me back? And then you need all sorts of transport concerns as well. So there's a lot of other things there. But like when we were doing that, let me actually try to locate one slide here which really shows this. Is there a go-to that's actually readable here? I think it is, yeah, beautiful. When I showed this slide here, what you saw is this. when we schedule things, we serialize the state using, in this case, an anonymous type. Anonymous types in reality are not serializable, but we could actually go one step further and say the thing that's passed to the scheduler is serializable. So we're actually giving it all the state it needs to operate on, which means that everything in the scheduler, like the states and the actions, is really all there is in the system. So we could actually take down the system by just serializing the entire scheduler queue with all the operations inside of it. And so that would be a logical place to actually put the checkpointing. So what we did in RxP2 was actually make everything go to the schedule overload that does this. What do I mean with that? Well, in the past this thing was actually executed differently, or was actually built differently. It was actually built like this. This is really too big, 16. So in the past it wasn't doing this. It wasn't saying I'm gonna give the state to the scheduler and then unwrap it again inside. What we were doing was something like pass in null over here and then do observer on next, observer on completed, and value over here. What's happening now is those things are captured from the outer scope, meaning C# generates a closure which is not serializable, blah 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 blah. Lots of stuff is happening here implicitly. The language is very powerful to do that kind of stuff. But because of that, we couldn't actually pick up the state and send it over to a different machine, for example. Say this observer is a Marshall by ref observer that you can call back to. So when you actually send it to somebody else, you get a remote proxy, a transparent proxy. Like, it wouldn't happen because it's sort of buried in a private field in a compiler-generated type that's not serializable. It would blow up immediately in your face. So we actually went through the exercise of everything that goes into the schedule method, making that serializable. We're not really using it today to build remote schedulers, but in theory we could actually use that to build remote schedulers, which also means we can serialize all the state in the pipeline, which also means we could do checkpointing. Long story short. But so today we don't quite have it built in, but you can actually put it on the edges yourself. Does that sort of answer the question? By the way, if you actually include Rx in, for example, Stream Insight, where they have checkpointing capabilities, the Rx pieces themselves are some of the artifacts you can deploy. They actually have a lot of verbs, run, deploy, and those kind of things. And you can actually create lots of artifacts, like subjects, which are things where you push things in and then they flow through a pipeline. So you basically deploy all of those puzzle pieces and then you cook them up, or you hook them up in some way. Rx pipelines, enumerable pipelines, some other CAP stream related artifacts, or I don't know exactly what the types are, but some of those are actually marked explicitly in the documentation as those don't allow checkpointing. So checkpointing happens on the other artifacts that actually support it, like some of the pipeline, that kind of stuff. So there's some mixed world there, unfortunately. Yeah. Okay, other questions? Yep.
Could you just briefly describe again what is Stream Insight?
Okay, so Stream Insight is a complex event processing technology that's actually built in the SQL team. It comes from a different angle. So I would actually say there are two fundamental differences. Okay, one difference with Rx is it doesn't support higher order streams, or we could also put it a different way. We do support higher order streams. Why do I make it that subtle? Because they grow out of a database technology. So they basically say, the way we model events is an event really occurs based on an insert in some temporal table. Events are raised by an insert in some way. The event is happening. It could even be updated because things are out of sync, you have some kind of synchronization points and all of those kind of things. So you can even think of events as being updatable in some way. And then you have the delete statements, which correspond to when an event ends. So you have, insert and delete are sort of boundaries on an event. And then you have edge cases like point events and longer events, those kind of things. So time is built into their engine, it's sitting everywhere, which means, every event has time information on top of it, which makes it, pretty powerful for a lot of queries that you actually want to ask there. But that sort of falls out of not having higher order streams as well. And so the higher order streams is if you have streams of streams, you can mimic time and you get a lot more power in return as well. So that's really one of the, or some of the differences between the two technologies is time built-in is their higher order notions, like can you have streams of streams. Like database technologies typically don't have streams of streams. Like if you look at SQL or relational databases in general, if you do a group by, it's sort of the illusion that you have a table of tables, like a table of all the groups, right? But the first thing you have to do is you have to flatten it again by aggregation. Like you have to sort of flatten that whole thing again into a rectangular structure. Like that's one of the things that you also get in systems like Stream Insight. And that gives for like constrained language, a language that's, you know, pretty powerful per se, but you can't sort of like go outside the boundaries pretty easily, unless you build your own adapters and all sorts of like funky stuff. And so one of the ways I think about like the world today, like is you can host RX queries in Stream Insight, so you can get more capabilities, more power, so that's better together. Sorry, you can use observables on the edges to feed things into the Stream Insight engine. Stream Insight has checkpointing, we don't. So like if, for example, you want to do checkpointing capabilities, you may use Stream Insight for that. If you have deployment concerns or like, you know, management concerns, and you say, you know, I want to have a service that I have sitting here, and I want to basically deploy things to it, and I want to have like artifacts that I can manage the lifetime of, and all sorts of things there, then, you know, a service is nicer. But we have purely a library that you can use everywhere. So they serve like complementary needs. There's a lot of overlap, which we recognize with like Stream Insight 2.1 using RX, and like, you know, RX being integrated into it. But at the same time, like, we don't want to be necessarily a server. Like, you know, RX says we're a library. It runs everywhere. It runs on small phones. We actually have a build for micro framework somewhere internally as well. Like, it runs on very small things. And like, we don't want to have a full-blown server around it. And so all the things you can think of with a server, you can also sort of add to the picture. And for example, something like Stream Insight, they might grow into a cloud service. They're working on those kind of things. So there's a lot of like grow outs of that, which are then services, servers. Like we say it's a library, you can rehost it, and we see a lot of people using it. Like SQL Server Power View is one. The Bing team is using it extensively. System Center, next versions of Windows Server, like they pick it up and they say, you know, the only thing we need is the library, and we hook it up in those places, and we have our own infrastructure around that. Like it's as if like you say, I want to have. And now I'm actually almost going to make a joke about something that sort of failed. But like, it's almost like saying, you know, we have a file system, but we also have SQL Server. Why wouldn't we build a file system on top of SQL Server? Like, you know, that works for like a lot of the metadata capabilities, but at the same time, it's a huge dependency to take in. And how does something like SQL work? Well, it needs a file system, right? Like so like you have this like sort of sandwich kind of thing. And so unless you can turn the whole thing upside down, then you have another layering, but maybe it's not the cheapest one. And so RX is for the lightweight libraries, and it actually fits in Stream Insight really well. So that's long story short there. Yeah. And I don't know anything about licensing differences. Like, you know, we just library use it wherever you like. Stream Insight has some licensing aspect to it as well. Nice music, yeah.
One more question. How can we close partial streams based on, let's say, every 24 hours we want to close our partial streams and start new one? Let's say stock exchange, and let's say we want to follow 24 hours and then close it and then open.
Open a new one? Yeah. So that's a hopping window kind of construct, right? Yeah. So we actually have two things in RX. We have buffers and windows, okay? And so they basically support everything. Windows with overlap, windows that are hopping, like all of those things are supported there. So just to show you the menu really quickly here, observable dot, let's first go with buffer. Buffer in general says I take in an observable of T, and I give an I observable of list of T, which contains the things in the buffer. When our buffers send out, they're sent out at the end, right? Like, you know, the buffer is full, we send it out. The buffer is full, we send it out. So that's what those guys do. There are 10 overloads to that. There are the count-based ones. So for example, this one does exactly what you want, but without time. So this one says, I want to buffer things with a certain count, like 5, which means get the first 5, then the buffer is full, we send out the buffer, and we create a new buffer, and the next 5 go into a new buffer, and then a new buffer goes out. So like it's really consecutive. You can't miss things even, because like you're blocking the pipeline at the point you're swapping out buffers. So that's what we have here. Then you have the ones that take in time spent. So then you can say like, I want to buffer things based on 1 hour. So I get the first hour, the second hour, the third hour, and at the end of the hour I get all the data in that hour. Then you have some higher order ones. In fact, I've just added an overload last week that actually will give you 2 observable streams. They say we create buffers every time the second stream says like create a buffer. So like one stream is actually a data stream, the other one says create a new buffer, create a new buffer, create a new buffer. We actually have one that does that kind of, but it's more higher order even. It's like, we create a new buffer and then we ask you to tell us when the buffer has to be closed. It's all really functional. So I created a simpler one for that. It's not in RxV2 yet, it's just checked in. But so that's the buffer ones. And then window ones are exactly the same. If ever you see window and buffer, now I'm going to make a big promise here. If ever you see window and buffer having a different overload count, we have a bug. That's what I'm sort of saying, like, because they're really the same. But so window gives you an observable of observables. And so what window does is like, you say I want to window this thing based on 1 hour at a time, which means at the very beginning you get an inner stream that will be lasting for 1 hour, and then it will see it uncompleted. All the values that happen in that hour are being projected into that inner stream. And so you can do aggregates on that stream, rolling aggregates, because buffers keep all the values, right? Like if you just want to sum them up, maybe you don't want to allocate a list that contains all of them. So it's exactly the same thing, but the resulting type is IObservable of IObservable. And so you have hopping windows, overlapping windows, you have basically all the things. And if something is missing, let me know. We also have the thing called the ferry buffer, by the way. That's something we came up with, this word. It's actually not called like that, but that's what we call the ferry buffer. Actually, we have good doc comments as well in RxV2. Like, we didn't really have great comments in RxV1. Spent some weekend of sort of like talking about this, and actually it uses the word ferry in here. It's kind of interesting. So this one takes in the source, a time span, and a count. And so what it says here, a useful real-world analogy of this overload is the behavior of a ferry leaving the dock when all seats are taken, or at the scheduled time of departure, whichever event occurs first. So it means like, you don't have to sit and wait in your boat because it's only going to leave at like 10 o'clock if all the seats are taken. Like, there's no point in waiting, right? So this thing basically says, send out the buffer or create a new window, which are like the converses or like the analogies. Whenever the time span fires or all the seats in the buffer are taken already. So that's an overload we found kind of useful for some cases. Yeah. More questions or dancing?
So I'm not sure if maybe that you kind of answered this indirectly by answering about the checkpointing stuff. The things that are kind of uncomfortable about, like your example saying 24 hours or an hour. Nobody's going to leave a process running for 24 hours, and you define a stream or an event stream. The process restarts. Okay, then starting from zero again. Is there a way? I mean, is it?
There is definitely a way to do that. So. Depends where your data is coming from. Like if all your data is tunneled to a scheduler, like if you say, the way I'm gonna do like create sequences is by basically having a virtual time, or we call it the historical scheduler. Like that's the place where things are running. And so what's happening is all your sequences are powered by those historical schedulers, and they have a clock that says like what the time is. So now the question is, will you fail expectedly or unexpectedly? Like, is it a failure recovery situation, or is it like a graceful shutdown option? If it's graceful shutdown option, what you can say is like, I know my historical schedulers that are firing the events here, they have a clock, they have a queue of work. So I can look at the clock to see like how far they are in their execution of time. Like this guy is at 1 a.m., this is at 1 a.m. and 1 second, like you see all of those guys. You basically ask all of them, you would have your own implementation of the scheduler, you just derive from our base side. And you would say, take everything in the queue after that time and basically put it in a disk, right? Like you could really serialize everything in there to a disk. And then when the process starts again, the first thing you would do is you would actually have all your historical schedulers do something like read from file. So they read all of their stuff. And of course, because it's an observable of t, you will have to make sure that your t's are serializable. And we'll make sure that everything that's being scheduled ultimately will have like those state parameters that are serializable as well. So there might be a lot of junk in there that you've never seen before, like which is our state that happens to land on the scheduler. But so you would basically read all of that stuff in again, populate the priority queue. We actually expose the priority queue of T type now in our XP2, so you can just enqueue things in whatever order and we'll sort them. And then we have a priority queue. And then the first thing you would say, you would serialize two things. You would serialize the queue and the clock, so that you know where the thing was, right? Maybe you're serializing the whole thing and you're not pruning it or something. And then when you deserialize the state, you have your queue. You would basically call on the historical scheduler. I think I have it sitting here. Historical scheduler of, S. So on S, you would actually say advance to the time you left off. So you would say advance the scheduler to the time you know the system was stopped. And so at that point, you know, the scheduler will actually position itself in that queue and then start executing all the actions after that thing. And so the way you would structure your code is you would have a query. At the end, you would have to say s.start, which is the scheduler starts running and pumping stuff. And in between, you would set up all your pipelines. So then the question is, how do you write your pipelines? Your pipelines might be just, you know, an initialize method that just takes in the scheduler and runs or builds all of the queries, right? Like, you know, you have all your sources, you build your query. But like in general, we don't put something underneath static void main or something that we know, like, or that we have the scheduler sitting there. So we can't pick up the process per se. So you would have to do exactly the same startup path yourself. You would say, you know, I have the historical scheduler here. I have access, which is a function that depends on S. I have like var y's, which is a function that also depends on S. And then I have var g's, or I have var result, which is my streaming query, where I do something like, you know, access dot take until y's dot blah blah blah, like whatever your query is, right? And so you would have one startup path that actually goes from like, it's the first time I'm running, I'm doing all of these steps, or like if I'm recovering, you would say something like s dot read from file, blah blah blah, and then you would say something like s advance to the time I actually left off last time. And then you would have exactly the same initialization code, of course. Now, one thing is, if this thing has something like select x goes to, and then in here you have some code, right? Like, you know, you would project this, it's a lot of dots now. So, like, you would project this thing onto some piece of code you're executing, and say somewhere in the outer scope you have like var n equals 42, right? And then this thing here is constantly mutating 42 for some reason. Like, I don't like mutation that much, but like, say this thing sometimes does an n++ or whatever. Like, of course, your checkpointing would have to take into account this thing as well. Like, you would need to know all the places in your query where things sort of, you know, are being mutated. And so in general, like, if you don't mutate things from queries, there's no problem. But that's what you get from a library like Rx that's actually purely a CLR library that's based on delegates. It's not like in SQL you can't really do like evil side effects necessarily in all kind of places. Like, you know, the language has some kind of constraints, and it's maybe not in a disciplined manner, but like in general you don't fall off the ship at some point. In this case, it's just delegates, right? And you know, your delegates might use something that's not serializable, they might mutate something, they might launch the missiles. Like, yeah, if you launch the missiles, like, yeah, you could checkpoint that, but I don't know whether that means like the missile has to suspend somewhere in the air till something else happens. Like, so you have, you know, the responsibility of dealing with the side effects there, and that's in general what makes it hard to do the checkpointing kind of stuff. And quite frankly, like, to me, the checkpointing would be more like virtualizing the entire process and sort of suspending the process and just resuming it in some way, like by hosting the process. as opposed to trying to get this part of the CLR heap and that part of the heap and that part, and sort of like trying to serialize everything. And so one thing you could actually look at in that context, and I'm not going to say more about that, is this project called Drawbridge. In fact, you know, I don't know whether we have a public release of that yet, but that's something you should sort of like keep in the back of your mind of like how you can do things. Like, how many of you have seen Drawbridge before, or heard of it? Okay. It's a library OS, and we're actually using it in Azure. So what this thing actually does is it virtualizes a process. So you have a process like Excel, it's running, okay? And that process actually has a lot of things it has to talk to, like kernel, GDI, Win32, NTOS kernel, blah, 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 like a lot of stuff. What did people do to basically virtualize that workload before? They said, let's just create a virtual machine that installs the entire Windows operating system, and it's like 20 gigabytes in size. That's the way I'm going to virtualize one Excel thing. That's a 20 megabyte process. If you want to do high density web servers, oh, you know, I have multi-tenant hosting environment. And like Bank 1 and Bank 2 say, I don't care how secure your stuff is, like, and how secure isolation between IIS websites is and application pools. I want to be in my own isolated, not even process, in my own isolated virtual machine. Then you're the poor hoster that says, this bank and that bank cannot be together, so I need two virtual machines, which is like 2 times like 4 gigabytes of RAM that I need to reserve, and all sorts of weird things that you need to take into account. So what does Drawbridge say? It's actually a library OS, which is something that has been established long before. They haven't invented that concept, but they've brought it to Windows NT. And that basically allows you to take an application that's running and say suspend. And then you basically get a file, like for Excel running, for example, you get a file of like 10 megabytes or something, or 40 megabytes or whatever, and you can just copy it to a different machine and start it there. It just runs. Like, so you're really suspending the executable underneath, as opposed to trying to say like Excel has something on the heap there it can't recover, and it has something over there that it can't recover, but that's actually in the recovery XLSX file or something, or the tilde file. I don't need to recover that. And like your head explodes if you try to do it from the inside. So they say we do it from the outside, but not as brutal as saying let's create a whole machine for that, right? And so that's actually what Drawbridge does. And it's actually been used for certain workloads like IIS, as you can see over here. But so that's something, when I'm thinking of, and that's one of the things we do in our team quite often, is like sort of scrutinize certain ways that things have been thought out before. Like, you know, like if the standard answer, like if you ask something to another team and you say like, they say like, that's obvious, you just use method foo to do that kind of thing. The it's obvious prefix is sort of what sometimes raises a bell to a team that does a lot of like those experimental efforts, and RX is one of the things that got very mature out of that. But like we're doing a lot of noodling around ourselves. When people say that's obvious, sort of means either it's established knowledge that they have sort of inherited from like 15 generations, and at that point it was established, or like maybe there's something fundamental and then we want to dig to that fundamental thing, right? Maybe it's a law of physics that you can't get around or something. But like things like taking something and like suspending it in the past was prohibitively expensive, or it didn't work, like for various reasons. But now that you have things like this that actually go beyond that, like maybe there are different ways of suspending workloads and re-executing them somewhere else. And so that's something we are sort of playing around with in the context of different projects, not RX per se. But like as I look more into it, it looks promising for things like checkpointing as well. But that's a random thought. Like I haven't proven that it's feasible or not, but like it feels like a different kind of thing in the context of not owning the execution environment. Like we don't own the CLR execution environment. The CLR doesn't have a way to suspend all of its heap operations and put them somewhere. But this thing sits low. And if you have something that's sitting higher, maybe you lose things. Like you say, you know, you have RX sitting here, you can do aware, but in the where you can't do side effects. How are we going to check that there are no side effects? Do we need our own compiler? That kind of stuff. And like, that's a slippery slope. So maybe it's better to say like, do all the side effects you want, but then we need to do virtualization at a different layer. So it's something else to think of. But, that's what I think of when I go to bed in the evening. Like, maybe you could do it this way or do it differently.
It'd be cool if you could take a checkpoint without suspending the application.
Mm-hmm. Oh yes, yeah. I think like that, like suspending and continue to execute kind of thing. Like, is if you have this and you can suspend and basically like write things to a disk or something and resume immediately and do something like differencing files, like VHDs do, then you have exactly that capability, right? Like you have a safe point to go back to. The thing is, of course, like this thing might reach out to the network and talk to a different machine, and then the question is, what do you do with that? Like, and do you end up in like transactions which don't quite work in a cloud context? Like all sorts of machines that have to agree at the same point in time that things are going forward or need to be rolled back. Like that's kind of slippery slope as well. But like just to point out one little thing here, like last week I was at TechEd in Amsterdam, and I was talking a lot to the Windows Server people that are doing lots of stuff, really beautiful stuff in like Windows Server 2012. And this is not like the time that there will be the little promotional spot or something entering on the screen here. I'm not doing marketing, but the thing is like they're doing a fundamental rethinking of the entire storage stack. And I learned a couple of things I never thought about being possible there. Like, I was talking to some of the storage guys, and in fact, like what they've done is like in 2012 they said like, we're not going to do something that's screwed on top. We're not going to say like, we're just going to add some capabilities at the top and some decoration in the margins or something to make the thing better. We're going to take a look at how we do flushing of buffers to the disk. We're going to take a look at the file system. Maybe we need a new file system, RFS, resilient file system. Maybe we need something else in the storage space for like SANs and NAS and all of that stuff. So they went the whole stack. And so there are some of those people that actually know a lot of the hardware and like what some of the hardware vendors are looking at. And so they talked to me about this thing that people are experimenting with in the hardware labs. There are some scientific articles on it and whatever, and it seems to work. And so what they're doing is really, I was really surprised that I never thought about it myself. Like, that's always what those hardware guys do. Everyone knows SSDs, right? SSDs are fast. Like, like you just write to it, like, no spinning disks, like beautiful speed of disks. But like then people say like, can you run like the whole Azure data center on SSDs? Well, like if you would ask Bill Gates to sponsor us, likely we could, but like that's really prohibitively expensive to have multiple terabytes of storage sitting there. So they have all those hybrids today as well, or you put like SSDs over there and or other disks like classic rotating spindles over there. And so one of the things they actually told me is like, it's not as black and white as you often think. Like there are some hardware guys who said like, what if we did the following thing? What if we said we actually have a hard disk that has 4 gigabytes of conventional RAM. Conventional RAM is dirt cheap. Like, no problem. Like 4 gigabytes of conventional RAM. And we use that as the hard disk. People say, well, your power is lost, that thing is gone. Like, doesn't seem good. Yeah, but we actually put flash behind it. That slow flash, which is cheap. So we put cheap flash memory, which is persistent, back in the back of that, and maybe a rotating spindle as well. Yeah, but what if data is actually in that RAM and the machine goes down? But what we do is we put a gigantic capacitor on that board as well. If your PC power is down, we're actually going to flush everything from that RAM into the underlying disk. We still have enough time to do 4 gigabytes of transfer there because we have enough capacity on there. What does that mean? That means all of a sudden all the hard disk writes to the operating system look like RAM writes. It's like a RAM disk, which means there's no memory hierarchy difference there anymore at that level. And that's something like I was thinking like, that's beautiful. That's like an interesting kind of thing. They haven't productized that yet, and there are various research institutes messing around with that kind of stuff. and likely it's like the power switch and stuff that is a lot of complexity to take care of. But like, it's those kind of shifts that I'm just pointing out. Like, this thing is also some kind of shift where people say it's prohibitively expensive to take a virtual machine around the whole thing. So we'll try to snapshot things from inside, and we're gonna, take out that byte array and serialize it, and this thing and that thing. And if we restrict the language this way, then we know sure there can't be side effects over there, so we can do this. And it's often like those kind of little things that ultimately come to fruition that actually guide you into a totally different mode of thinking. So,
on that, is singularity still being worked on?
I know the research guys have done some spin-offs of that, but for the rest I don't know anything about like singularity. I know there are always spin-offs in like the research space, but yeah.
Pico, SLM, instead of .NET applications.
Yeah, that's actually like for those of you who haven't seen Singularity, actually the guy who did, or the folks who did Drawbridge, Galen Hunt and people, are actually the ones who did Singularity as well. And so Drawbridge is actually taken into production today, like with things like in Azure they're using it for some of the lightweight hosting capabilities, I believe. And so,
Should we take the rest of the questions in the bar?
Oh yes, a bar. I like a bar.